Yo, what's good? What's good? What's good? Hey yo, how are y'all doing? Guys, been 9 months of grinding. We're here for the last segment. Well, part one of the last segment, innit? I respect the hustle. That's a W. That's a W. Let's get some W's in the chat. Let's get some slay in the chat. Respect to you guys. Thank you for putting your trust in me, especially the day before your exam, guys. Love for that. I'm gonna do my best to accommodate your needs the day before your exam. Slay. Revision dump. If you can't print the workbook is in the description, guys. What we're gonna be covering today. If you can't print it, just get a piece of paper and just copy along. Remember, this is all recorded. You can re-watch it tonight, tomorrow morning before the exam. Is the exam morning or afternoon? So you can go through all of that beforehand. We all getting the top grades with this stuff. So, morning. Okay, cool. So on the bus, on the 114, you guys can go through this stuff again. Maybe timestamp wherever you think you need to revise. So obviously, guys, we're going to be going on for about 3 hours. Maybe I'll go on a little bit longer. Um, I'm going to cover everything that I have planned. So obviously, I can't cover absolutely everything. So I recommend that you watch all of my YouTube videos for GCSE, watch all my TikToks for GCSE. As you can see, the at symbol here, Neil does GCSE maths. Now, guys, uh, your friends need help too. We're all in this together. Shout out High School Musical. So invite them to the stream. Just share the link with them. It's all free. Like I told you, I'm trying to make as many things free for you guys as possible. I also have some more free stuff coming to you guys soon. So you don't want to miss it. So stay tuned for more free stuff that I'm going to be sharing with you later on. Just a quick introduction about myself if you don't know already. My name is Neil Trivedi. I'm the head of maths at My Headspace. I'm a fully qualified maths teacher, over 9 years of teaching experience. I have a first class maths degree from UCL. Also, I sat my A-level maths when I was 16 years old, got an A star. And a cool stat for you guys is 73% of my September cohort, so students who joined my courses in September, achieved a grade 7 to 9. 73%. The average is 20%. So you do the maths. That's pretty decent, white. What? Yes. Hey yo, you guys are jokes. So guys, before we begin, it's subscriber only mode. So if you want to communicate in the chat, if you're watching and you can't see how to communicate, just make sure you are subscribed. And that way you can communicate. I'm going to be reading the chat as much as possible and answering your questions. Guys, I'd really appreciate if you hit the like button. It helps me out a lot. It also increases the reach to make sure that as many students gain the benefits of this lesson. Thank you guys. We've already hit 200. Maybe we could try get to like 300, 400. I'd love that. Thank you guys. And turn on notifications because I'm uploading GCSE videos as much as possible. And we have more cram courses, guys. Maths, biology, chemistry, physics, English. Link is in the description. So let's make a start, mate. So we are focusing on non-calculate. I'm going to cover the most important questions I think will come up tomorrow. And a note to you guys. There's no such thing as predictions. Don't let anybody tell you they have predicted what's coming up tomorrow. It is an excuse for students to be lazy and think that they should do one predicted paper for tomorrow. Those students do extremely terribly. Okay? So stop asking about predictions. They don't work. The top students don't look at predicted papers. Okay? So we're going to start off with indices. Find the value of x in the following. What would you guys do here? 3 to the power of x is 3 times the cube root of 3. Anything here is a key piece of information that you guys need to know for your exams. Okay. So Yusuf A, you said 3. What do you mean by that? Key re. Respect. I saw you in the chat really early on. Now, a lot of you are getting 4/3. What we're thinking about, guys, is we're thinking, what is this question even asking us? It's saying 3 to the power of something is all of this. Okay? 3 to the power of something is all of this. Now, the problem is that this is an unsimplified expression with base 3. So what we could do is just rewrite it as one base and combined. Okay? So we know 3 is 3 to the power of 1. But the cube root of 3 is 3 to the power of what? Uyan, it is. Good. So let's do it one step at a time. One step at a time. Ariana, good stuff. Max, good. 1/3. So this, guys, comes from rule 7. Rule 7. Yeah? So fractional powers tell us which root we're taking. Okay? So the fraction tells us which root we are taking. Okay? Now, when we multiply two numbers with the same base, what do? I don't know, Heizen Biryani. What happened to him? Good, we add them. So this is rule 1, the most important rule. Yeah. The first one that you learn in year 3. Yeah, when you multiply two numbers with the same base, we add the powers. Whoops, that's supposed to be a 3. Now, technically speaking, 1 plus 1/3, you can say 1 1/3, but I would prefer it as an improper fraction, Hannes. Exactly. So yeah, that's 3, 1, and 1/3, but let's do it as an improper fraction. So we multiply. 1 times 3 is 3, plus the 1 is 4. So we get 4/3 for him. Good stuff. Gemma, good stuff. So what we've done is we've said, if I write again, 3 to the power of something is 3 to the power of 4/3. Well, the only way that they are the same is if the powers are the same. Okay? X is 4/3. Another question is, if I had root 3, what would the power be? Say I had root 3. That's 3 to the power of what? Because technically I haven't got a number there, right? If I have root 3, that's 3 to the power of what? Good, Dev. Fahim. Eb. Good. A half. Yeah, so this is technically a square root. I mean, really, we just say root. There is an invisible 2 here. Okay, we don't need to write it. So it's 3 to the power of a half. That's a very common one. So guys, make a note. Very, very common. Okay. Yo, Zane, what are you saying? All right, next one. So remember, guys, we're just going to try and cover as many key topics as possible, all right? So next thing we're going to have a go at is solving quadratics by factorizing. These kind of questions, guys, can be worth a lot of marks in the exam. It says the area of a trapezium is 119 centimeters squared. Show that 2x squared minus x minus 120 is 0. So, Abbas, yo, welcome back. The key, guys, is always look at what the question has given you. It says the area of the trapezium. As soon as you see that, you should be quoting what the area of a trapezium is. Okay, spot the taste. Good. User. Good. So the area of a trapezium, is a half h, yeah, half height, a plus b. And there's obviously different ways you can represent that. You could write h, a plus b all over 2. I like to write half like this. Okay. Now, in general, guys, a plus b, what does that mean? What are the a's and the b's on a trapezium? Can you define it for me? How would you describe that, Devon? Base? Be more specific. Good, Pranav. Dev, Joseph, good. So, guys, be careful. Do not say top and bottom. Okay? Because if I rotate this, you wouldn't tell me top and bottom. Whoa. Neil does drawing. Yeah, you wouldn't say it's the top and bottom here, right? The A's and B's are the parallel sides. Yeah, the parallel sides. And I've indicated that using this right angle to show that they are parallel. Okay. And then H is the distance between them. So there's the parallel sides, and this is the distance between them. All right. So in our case, I've told you the area is 119 is a half of H, which is x minus 1. Then your A plus B. So your A, and here's your B. Those are your parallel sides. So we have x plus 6. And we have 3x minus 4. All right. So we have 119 is a half. I'm going to be showing you guys a few tricks in this lesson, all right? So you have x plus 3x is 4x. 6 minus 4 is 2. What would you guys do next to solve for x? Jonathan, 90. Okay, Toby, you're saying times by 2 on both sides? Rabika, that's actually what I'm going to do. Run it. Okay. Now, guys, multiplying by 2 on both sides is correct. You can do that. However, there is something nicer you can do. Guys, look inside one of the brackets. What do you notice is special about the numbers inside one of the brackets? What do you guys notice about the numbers inside one of the brackets? I'm going to keep up. Yeah, Maka, good. M, good. So guys, you should notice that in one of the brackets, they are even numbers. Yeah. So instead of multiplying by 2 on both sides, why not just multiply in the half? Okay. You could basically just imagine that this x minus 1 wasn't there. Yeah, you only need to multiply the half into one of the brackets, all right? Not both of them, just one. So guys, when you multiply in that half, what do we get? So just imagine that x minus 1 isn't there at the moment. So this will make your life a lot easier because remember guys, in a non-calculator paper, you want to utilize as many techniques to make your life easier when solving. Because if you double both sides and you double 119, you then have to half everything afterwards to then simplify. It can get messy. Okay? Thank you. So it'll be 2x plus 1. So let's go up here. We have 119 is, so we still have that x minus 1, right? So that x minus 1. And then we multiplied in that half. You guys telling me it's 2x plus 1. Okay, so this we multiplied by the half. Now we expand. Yeah, actually, exactly. So guys, let's expand the bracket. Let's expand this. What do we get? Just make sure we know how to do that. Which by now, hey, I'm confused. What about the other side? The other side, nothing happens. That's just 119. Nothing's going on the left side, isn't it? Okay. Okay, so, Pack, will this be useful if I'm doing OCR? Now, obviously, OCR, their paper tomorrow's calculator. This can be helpful for your paper 2 specifically. So if you're doing OCR, maybe come back and rewatch this when you're doing your paper 2. But yeah, I don't know why OCR are bugging, why they have to swap things around. There's always someone who's got to be different, innit? So x times 2x is 2x squared. And then we've got x times 1 is just x. And then we've got minus 2x. X minus 2x is minus x. And then finally, we've got minus 1. Okay, then we got minus 1. Okay, then what do we do? What do we do, Mike? Nice, Joseph. Mohammed, good. So now we need to move everything to one side, right? So when we solve, we move everything to one side. We move everything to the side of the positive x squared term. Okay, so we're going to minus 119 because we always, when we solve quadratics, we need one side to be 0. So we get 0 is 2x squared minus x minus 120. And that, my friends, is proved. Now we need to work out the value of x. This is non-calculator. The only way to solve this is by factorizing. Okay? There's different ways you can factorize. You guys know how I like to solve quadratics. Um, but you guys can do whichever way you want, all right? By now, I'm hoping you guys know how to factorize, but I'm going to do the oi oi method. You guys know, if you want to use the AC method, go for it, all right? So, oi oi, factorizing. Don't worry, Jonathan, I'm going to explain. It's just like factorizing as if there wasn't a 2 there, okay? So guys, you're saying, what multiplies to give you 2x squared? That's going to go here and here. What are we going to put there? Param, dodgy dive mite. Good. 2x and x. Yeah, so guys, we know 2x and x. So to make this, we need 2x and x. I'm going to give you guys some tricks here as well. At this point, guys, if you are using the AC method, stick to it, all right? So you've gone your whole career using it, stick to it. Don't change your method for tomorrow, okay? And the last thing is we need to look at the factors that will make 120, okay? So what have we got? We got 1 and 120. We got 2 and 60. 3, 40. Quattro. Wait, did I say? Yeah, quattro and 30. Hey, yo, this guy's bugging. 5 and what? 24. So you should go through the motion here. 5 and 24. 6 and 20. And I'm going to show you guys that there are some options that we don't need, okay? 7 doesn't. 8 does if you half it 3 times. So guys, to divide a number by 8, you just half it 3 times. Half of 120 is 60. Half of that 30. Half of that 15. Nice. And we got 7, no. Wait, I did 7. 9, no. 10, yes. 12. All right. Now, I know some of these options are not allowed. Does anybody know which pairings are not allowed to be used here? Which pairings are not allowed to be used? S, Ikra. Nice, Mohammed. Jake, well done. So guys, any option that has 2 even numbers, Hannah, well done, are not allowed. Okay? I'll give you an example, guys. Don't write this down. I'm just going to show you why you cannot have an even pairing. Because if I put 10 and 12, for example, here, what do you guys notice about one of the brackets? No, if I put 10 and 12 there, what do you notice about one of the brackets? Mansim, good. So guys, if you look at the first bracket, can you see there's 2 even numbers? You'd be able to factorize out a 2, but you can't factorize out a 2 from here, all right? And even if I swap them around, it doesn't make a difference. And this is why even numbers, anything that has 2 even numbers would not be allowed. Okay, so we can cross those out. Okay, which is the next option we should go for then? Nice, Nigel. Which is the next option we should try? 8 and 15, good. Now with 8 and 15, the 8, does it need to go in the first bracket or the second bracket? Which one would you guys put it in? The first or the second? Naylor, good stuff. Good stuff, guys. We're raising the grey boundaries with this one. The 8 has to go in the second because we're not allowed 2 even numbers. All right? So 8 here, 15 here. All right? What's up, Neymar? Now, we do oi oi. Okay? Now, oi oi comes from FOIL. My method of oi oi comes from FOIL. So you just need to expand the outer and the inner, and then you check your answer. Okay? So 2x times 8 is 16x. This makes 15x. Is it possible for 16x and 15x to make minus x? Yes or no? Is it possible? Dara, that question about the x minus 1 explained it when I did the method. Okay, so just flick back later on. I did explain why I didn't multiply in the half. with the x minus 1. Good, it can. Guys, you need minus 16 plus 15. And there you go. So you need a minus here to make it a minus 16x and a plus here to make it plus 15. Okay? So now we have this. We factorized it. Now, obviously, I'm explaining my method. But in reality, guys, this takes you like 3 seconds to do. Okay? My GCSE students can do it in literally seconds. What do we say next? What do we say next once we have factorized? Nice, Mohammed. Lux, why? 3 whole seconds, I said. Izzy, how? Yasin, you are right. Bloof, good. So, guys, we're saying 2 things multiply to give you 0. Okay? Now, the only way for 2 things to multiply to give you 0 is if one of them are 0. Okay? So, either 2x plus 15 is 0, or x minus 8 is 0. Now, when you solve for x here, guys, what do you get? You should write down your answers for both of them. Even if, Rashid, you're right, one of them can't be negative. Still write it down. Still write it down. Okay, good, Safa. So we minus the 15, so 2x. A plus 15 on the left is a minus 15 on the right. And then we just divide both sides by 2. Okay. Now we know, guys, that x has to represent a positive number. It actually has to be bigger than 1. Because if you substitute minus 15 over 2 here, it's going to be negative. Okay. So we're going to say, but x minus 1 needs to be positive. So this is not an option. Okay. So this is not an option. So our only option is 8, aka ocho. Practicing my Polish. Ocho! Let's go. Now this would be a juicy question in the exam. Alright, so part A could be 3 to 4 marks. Okay, depends on how generous the examiner is feeling. And part B, 3 marks. Okay, Jake, it's worth a lot of marks. Yeah, I'm not here to do easy questions today, guys. Yeah, I don't believe it's appropriate because you should have really been practicing the easier stuff already. Okay, so that's not Polish. Hey, I do know Polish though. Dzień dobry, dzień dobry. The next thing that is a very, very, very common question in non-calculated papers is rationalizing denominators. Okay, thanks, praises. Now, sometimes we have to do more. We will have to do more than just one term or rationalize more than one term in the denominator. When this happens, we need to use the difference of 2 squares principle to rationalize the denominator. Okay, you guys know what the difference of 2 squares principle is, right? Let me check your knowledge. Factorize x squared minus 25. Alright, say no more. Say no more. Prove to me that you know how to factorize x squared minus 25. Yo, Parry. Alright, good. So, difference of 2 squares is saying, okay, these are 2 square numbers where you're taking a subtraction. You're just saying, what multiplies by itself to give you x squared is x. What multiplies by itself to give you 25 is 5. One bracket has to be plus, one bracket has to be minus. And the reason for that is in the middle we have 0x. So you just have to make sure these numbers add to give you 0. Okay, that's all. Okay. So if I want to simplify this by rationalizing, just to make sure, guys, that you are clear with how we do this method. If it was just over root 6, what would you do? So don't write this down just yet, guys. Just pause. If it was just root 6, what would you times top and bottom by? Zamzam, of course. And she, good. So, and a very good thing, guys, is if you do know the answer, you are reiterating that you understand the principle, which is great for tomorrow, okay? So, and hopefully a lot of the things that we're doing today, you do know already, which is just giving you more confidence, all right? So if it was on its own, you would have to times by root 6, okay? Because when you times a number by itself, you are squaring. And squaring a root cancels the root, okay? So that would be 3 root 6 over 6. All right. Would you guys leave your answer like this? Yes, James. Man like Jarmers. Salt, good. Yeah, so guys, they don't need to say this to you, right? You do need to simplify. 3 does go into 6 twice, so it'll be root 6 over 2. All right. Now, let's go over to the actual question. It says 3 over root 6 plus 2. Are we allowed to just times top and bottom by root 6? Are we allowed to just times top and bottom by root 6? No. Well done. The problem with that is if we times by root 6, we would have to times the 2 by root 6. All right. Now, what should we do with the denominator? Just rewrite it slightly or put something around the denominator that will stop us from making silly mistakes. What is that? Yes, Safa. Good floof. Brackets. Ayo, Dominion, what are you doing in this stream? Ayo, nah. Nah, Dominion, get out of here. That's one of my A-level students. Nah. Dominion. Don't think I didn't see you. So guys, we put a bracket. Because then if you just times by root 6, yeah, you would have to times by the root 6 and the 2. All right. So we go through a different method, and that is to try and square this and square this by utilizing the difference of two squares principle. And we do that by multiplying it by itself. Yeah. But we have to change the sign. Okay. So we're just going to do the same to the top and the bottom. Okay. What does the denominator expand to give you? What's up, hey? Sure again 4. Izzy 6. L serpentine 2. Okay, so when we expand difference of two squares, if you guys go back to this example here, all right? If you have x plus 5, x minus 5, and you expand it, what happens to the middle terms? So when you expand this, what happens to these middle terms? What always ends up happening? Good, Matty. They always cancel, okay? So guys, this is minus 5x, and this is 5x. They always cancel, okay? So with this denominator, the same thing happens, okay? So you don't need to show this. I'm going to show you guys what you need to show in the exam. This root 6 times minus 2 and this 2 root 6, they cancel. You do not need to show that, okay? The only bits you need to show in the exam, because you know there's going to be cancellation, is root 6 times root 6 and 2 times minus 2, okay? Those are the only things you need to show in the exam. All right. Root 6 times root 6. Root 6 times root 6 is just 6. Yeah? You do not need to say root 36, which is 6. Guys, you just know root 6 times root 6 is 6. Root 2 times root 2 is 2. Root A times root A is A. Okay? Hopefully by now you guys know 2 times minus 2 is minus quattro. Now on the numerator, do we need to expand it? Yes or no? What do you guys think? This is if the examiner gives you a choice. Okay? Only if the examiner gives you a choice. Okay. Yoshida, good. If the examiner gives you a choice, you do not need to expand it. Okay? So guys, if the examiner gives you a choice, you do not need to expand it. All right? I'm going to give you an example where you would need to expand it. So for now, this is our answer. Okay? Give me an example of what this number would need to be where you would need to expand it. Give me a different number outside that bracket where you would need to expand the bracket if they didn't ask you. Good state. Guys, 6, you wouldn't need to expand it. So if it's a 6, you would need to expand it. Hey, don't copy each other's answers, yeah? 5th, good. Guys, the only time you would need to expand it if they give you an option is if there is a root outside. So for example, if it said root 3, root 6 minus 2, then expand. Okay? If it's just a 3, you don't have to expand unless they ask you to. Okay? Because this is not simplified. Okay? You can't have multiple roots here because the root 3 times the root 6 becomes root 18, which can be simplified. Okay? That's why. Whereas 3 times root 6 is just 3 root 6. Nothing's changed. Okay? So guys, if it was a 6, it doesn't make a difference. So if I had 6 root 6 minus 2, if you expand it, nothing changes. It can't be simplified. You get that, right? Nothing can simplify. Whereas with this one, you'd get root 18, which simplifies to 3 root 2. Okay? So guys, if there's a surd on the outside, yeah, if there's a surd, then expand. Okay? If there is an integer on the outside, then you don't have to unless they ask. Yeah? So expand only if they ask. Okay? You will not lose marks if you expand. Don't worry though. If you do expand it, you won't lose marks. So if we take a look at part B, what would you multiply top and bottom by to rationalize? This Kevlin Games, guys, is bugging. You need to chill out, mate. Yeah, Dowd. Mystic, good stuff. Beast, they're traditionally in non calculator papers, that's why. So, we multiply by the exact same thing, but we change the change the sign. All right? All right. Can you guys multiply out the denominator? You don't need to simplify though. You don't need to simplify just yet. Let's say 12 minus 1. Dragon Lord. That's with simplification. That's decent. Oh, we're gonna get uncooked. Oh no, that was Zara. Chat's moving so fast. Okay, cool. So here, well done, guys. You're gonna do 2 root 3 times 2 root 3. Now, when we do this, when we expand this, you multiply the numbers with the same property. All right, which is 2 and 2. We all know what 2 times 2 is. That's quattro. All right. And then we've got root 3 times root 3, which you already know is 3. So you have 4 lots of 3. Yeah, 4 lots of 3, which is 12, which you guys were saying, which is good stuff. And then finally, we got this minus 1. On the numerator, guys, if they don't ask, do you need to expand it? Yes or no? What about quattro? That's good. Ella, good. So don't waste your time unless they ask. Okay? So just leave it over 11. You will know, guys, you will know that they want you to expand if they say something like this. They'll say, give your answer in the form A plus B root 3 over C. If they say this, you can see that there's no brackets, right? That means you would need to expand. Okay? And if you did expand it, it would look like this. So you don't need to expand it. But if they ask to be in this form, then yes, you do. Okay? Yo, TB. Aisha, they always say that though. Unless you've done every single paper in the history of mathematics, then you can't say that. All right, inverse proportion. Very common in non-calculator papers. So it says a variable v is directly proportional to a variable s and inversely proportional to another variable t. When s is 3, t is 60, v is 0.5. Find the value of s when t is 5. All right, what would you guys write down first? What would you guys write down first? Sakana, v equals ks. So v is directly proportional to s. Now, guys, if you don't know already, proportion, when I say proportional, anyone says proportion, it just means some multiple of. Okay? So it's just saying some multiple of. So it's saying v is some multiple, and we like to use k. We don't know what the multiple is. Some multiple of s. Okay? And direct proportion just means as one value goes up, so does the other. Now, when we say inverse proportion, guys, we're saying v is inversely proportional to t. What would that be? What would that be? So it says and inversely proportional to another variable t. Tamzid, I see there, but it's still v. V is inversely proportional to t. So you can see how they can be cheeky with their wording, innit? Lara, good. Now, if I say this, guys, it is technically wrong. So don't write this down just yet. If you say this, it is technically wrong. Does anybody know why? Tell me why. Ain't nothing but a heartache. Nice, Hams. Welcome back. Dion, Philippines was great, man. But not the flight. Nat, good. Guys, you cannot use K again. Alright? If you use K again, you are implying that the multiple is the same. Okay? Libo, good. So you need to change it. Change it to something else. Alright? So either you say K1, K2, which I would prefer to say personally, or just use different letters. So you could say K1 if you want. And here we can say V equals K2. K2. Good, I like that. That's some good notation there, mate. All right. We're raising the gray boundaries with this one. Guys, I'd appreciate if you hit the like button. Maybe we can get above 800. Respect, respect. TV, get the gray boundaries down. I don't think that's what we're trying to do here. But luckily, it's just 2,500 people and not the 400,000 that take the exam. So you guys are in a good position. I respect it. Now it says when S is 3, T is 60, V is 0.5. Can you guys tell me what K1 would be? Thank you guys for the likes. I appreciate it. Love for the support. You guys in the top miniature percent out here. Izzy got 1.5, Alexandra 6, Synthetic 6, and 1.5. So it looks like it's between 1.5 and 6. Some of you getting 1.6. So let's see. I've said V is a half. V is a half. And S is 3. Okay. Now, the way I've written the numbers, there's something I would do differently if it's a non-calculator paper in terms of the way I write the numbers. Does anybody know what? There's something I would write slightly differently because it's a non-calculator paper. Max, good. Thanks, Param. Yo, Dogan. A half. So this, guys, we do not like decimals when doing non-calculator. So at every opportunity, you need to convert it to a fraction. So we're saying a half is K1 times S, which is 3. And then we know we need to divide by 3 on both sides. Okay. Now, when you divide a number by 3, yeah, so when we divide a number by 3, it goes to the denominator. Okay, the 3 goes to the denominator because of KFC or KCF. I don't know how you guys put that, but if you're from East London, then it'll be PFC. If you know, you know about PFC. So we got times by 1/3. Here's K1. So there you go. K1 is 1/6. Now, if I was going to give you guys more advice, is when it comes to non-calculator papers, do more steps than usual. Okay? Do as many steps as possible to ensure you get the correct answer. Okay? Dev, isn't PFC the gym? I don't know what gym you're going to, bro. It's a chicken shop. So we have 1/6S. Alright guys, doing the exact same thing. Can you guys find me K2? So we still have that V is 0.5 and now T is 60. Blaze, for real, for real. Change your plan. 30. Alright. Change your plan. We'll get them next time. So again, we're replacing that with a half. Is K2 Capisha? Good stuff. Divided by T, which is 60. And then we're going to multiply both sides by 60. Good stuff, Mike. A half of 60 is 30. So we have V is 30 divided by T. Right. Find the value of S when T is 5. Okay. Can you guys work that out for me? I've told you T is 5. Can you go ahead and work out what S would be? HB said 30. Spiz says 9. Hey, yo. Is it actually? I haven't done this question in a while. Yo, Quaver. I haven't had Quavers in ages, man. So when T is 5, V is 30 divided by 5, which is 6. But guys, I wanted S. I wanted S. Okay. So we've worked out V is 6 when T is 5, but we now need to use this one, yeah, to work out what S is. So we have 6 is 1/6 S. And then, nice, we're gonna rearrange by timesing both sides by 6. Yeah, 1/6 just means divide by 6. So we're going to do the opposite of that. We're going to times both sides by 6. Nice one, Dive. 36. Beautiful, mate. A question like this could be worth 5 marks in the exam. That's cheeky, mate. Nice one, Dive. All right. We're raising the grey boundaries with this one. Luckily, you guys are part of this scam, Ramina. It should be more than. Now, these questions are quite common as well, especially when it comes to non-calculated papers, is to identify the type of graph. What type of proportionality is this? Now, which one of these graphs represents direct proportion? It can only be number 1. Well, it could be more than 1. Which ones would you say are direct proportion? So I'm seeing everybody putting 1 RD. That is correct. So 1 is correct. There is another one. There is another one. Which one is it? Yusuf, that's you, mate. Now, it is not 3. Why? Does anybody know why 3 would not be classified as direct proportion? Hey, Scene. Nice to hear. Nice, Rabika. Good. It does not go through the origin. If we go through this last question, do you know, for example, this one here? All right. If I just change it to y and x, this graph here goes through the origin only. And when we do direct proportion, guys, it can only go through the origin. All right. Both of these do go through the origin. Yeah. An example for this is y is proportional to x. What could this next one be? Y is proportional to what? It does go through the origin. That's good. What could this one be? DJP, good. Dev, good. Waggy, I mean, it doesn't have to be exponential. Okay, we could just say, yeah, it's an x squared graph. Y is proportional to x squared, or x cubed, or x power 4. It could be any of those. So 1 and 2 only. Okay, let's make a note here. It doesn't go through the origin. Doesn't go through the origin. All right. Now, let's take a look. Inverse proportion. So we've got, which one of these is inversely proportional? So this one's saying amount of spicy food eaten and then confidence in your next trip to the bathroom. Then we've got loudness of snoring and your partner's patience. So just talking about you guys over here. Heard you guys been snoring too much, mate. Zara, good. Sorry, I got my tuna smoothie. Now, why is number one not allowed? Why is number one not allowed? Jasmine, nice. No, that's it. Just because it doesn't look right, it's not an answer. Good. It goes through the axes, the x-axis, which is not allowed, or either of them. Yeah, it's not allowed to cross any of the axes. Okay, so one is not allowed, as you cannot intercept any axis. Okay, because for example, in the previous example, we had this, right? Which was 30 over t. So like this, if we had y equals 30 over x, guys, what happens when you substitute x is 0? What's 30 divided by 0? What's 30 divided by 0? Good, Dev. No, it's not 0. No, don't do this, guys. Why you do this, man? John, can I do a door giveaway? That's crazy. Guys, you can't divide by 0. Essentially, what I'm asking you is how many zeros add together to make 30? It doesn't make any sense. Yeah, it's undefined. It is not infinity. Yeah, do not say infinity. That's mathematically incorrect. Okay. And same thing, guys. If you make y equals 0, you would get 30 equals 0. That doesn't make any sense. Okay. So number one is not allowed. Two only. Who knows the name of the lines where the curves are not allowed to intercept? Begins with A. Who knows what they're called? Good, Tab. It's a math error. Alex, good. It's an asymptote. Okay. Asymptote. All inverse proportion graphs need to have an asymptote. Okay. There's this guy on YouTube that quizzes people on the streets of the UK, and he asks them, uh, like, what's the silent letter in different words, and then they get it really wrong, and then he looks at the screen. I don't know if you guys know who I'm on about. He should do this word. You know him, Nicole. What's his? Oh, Iman or Eman, I'll call him. Yeah, Eman. He's goated, man. Yo, someone needs to tell him to do the word asymptote, which is the silent word in asymptote. Oh god, he's too funny. Man like E-man. All right, straight lines. Now, with straight lines, guys, they can ask some really easy questions and they can ask some really hard questions. Okay, I'm obviously going to do the more difficult questions that they could possibly ask. So it says a straight line L1 has equation y equals minus 3x plus 2. The straight line L2 is perpendicular to L1 and passes through the point with coordinates 3, 4. Find an equation of the line L2 in the form ax plus by plus c is 0. Okay, so we have a straight line, L1, and we have another line which is perpendicular to L1 and passes through different coordinates. Good, Dawn. Find an equation of L2. So obviously the first thing we should be doing is finding the gradient. Okay? The first thing we should be doing is finding the gradient of L2. What is the gradient of L1? What is the gradient of L1? Good. The gradient of this one is -3. Well done. Now, if you're perpendicular, what's the word we should be using if a gradient is perpendicular? Aish, good. Negative reciprocal. So the perpendicular gradient is the negative reciprocal of this, which is what? What is that? Good, 1/3. Because you can think of this as 3/1, right? So you make it negative, which would basically change the sign on it, and you flip it, so 1/3. And then it goes through this, all right? Now, if you've been watching me on YouTube or my student, you'll know what I would be using to find the equation of the straight line. What is that formula? What is that? Nice. Spiz. Jasveen. Good. Y minus y1 is mx minus x1. Okay, now I prove it on my YouTube channel. All my main course students use it. Just because most students don't get taught that way, I'm going to do both. Okay, y equals mx plus c is very limited. It works, but it's not the best formula. So, using the y minus y1 formula, you're going to say y minus the y coordinate, which is 4, is the gradient, which is 1/3, x minus the x coordinate, which is 3. Now, those of you who use this formula, what would we do next to put in this form? So to put in that form, what would we do next? Nice, Pranav. Dogan, good. We would times everything by 3. Yes, good. So we multiply. So here, guys, ax plus by plus c is a special form in maths for lines where these numbers here are all integers. Now, likely in the exam, they would mention that they're integers. We just need to multiply through by 3 to get rid of any fraction. Okay? You okay, yeah? All right. Remember, on the right side, there's only one term. So we have 3y minus 4 times 3 is 12. Here, that cancels. So we're just left with x minus 3. Now, the next thing we do is what? What's the next thing we do? Josh, add 12. You could go that way. I prefer moving everything to the left. I call it the Beyonce. So can you see, guys, one side is 0. It doesn't matter which way you rearrange it. I personally just move everything to the left. Okay. So the plus x goes over here to become minus x. So we have 3y minus x. Then we add the 3 over. Okay. Minus 12 plus 3 is minus 9. Okay. Now, if you use y equals mx plus c, if you use y equals mx plus c, which is the limited version of straight lines, but it's all good. So you would say y equals 1/3 x plus c. Oops, plus c. Then you would sub in the coordinates. You would say y is 4. You would have 1/3 of 3 plus c. You would have 4 is 1/3 of 3 is 1 plus c. You would minus the 1 from both sides. You would say 3. And then you would say y equals 1/3 x plus 3. You can see how many more steps are involved, but it's all good. You still get your answer. But now what would we do? If you leave your answer like this, you would not get the right answer. Emma, yeah, sure. Y minus y1 is mx minus x1. I just released a YouTube video on me proving it the other day, so feel free to check that out. So we wouldn't minus anything first. We would multiply by 3 first. Okay? So we'd multiply by 3 first. So we get 3y. 1/3 of 3 cancels x plus 9. And then you move everything to one side. Either you move it to the left or the right. It doesn't make a difference. Okay? So if we do it like I did, you get 3y. The plus x on the right is a minus x on the left. And then the 9 goes over. You get minus 9 is 0. Okay? So guys, you get the same answer. It's just here. Sophie, you know which one I prefer. This one takes 3 steps. This one took 1, 2, 3, 4, 5, 6, 7 steps. Okay? But guys, you get the right answer eventually. Okay? So you do whichever way you want to do. All right. Okay. Which one's better, mate? Which one's better, mate? So the line L2, just like the AC method, guys, whichever one you've been using so far, just stick to that one for tomorrow. It says the line L2 crosses the x-axis at the point A and the y-axis at the point B. Find the coordinates of A and B. So we worked out the equation is 3y minus x minus 9 is 0. How do we work out where it crosses the x-axis? What do you need to do to find where something crosses the x-axis? Go, Pranav. Robin, should I just go straight to the beginning again? Mystic, so what do you set 0? So guys, when you say set 0, you need to say what? Potato, good. Y is 0. So guys, on the x-axis, yeah, on the x-axis here, all the y values are 0. Okay? Quaver. That's it. So for the x-axis, y is 0. And it's very easy for you to solve that. You could basically use your big toe to cover this up, because that's setting y to be 0 and rearrange for x. What did you guys get when you solve for x there? Nick, Hockey is doing good. He's probably in the chat somewhere. Lurking. S9, good. So you have minus x minus 9. So be careful, guys. Sarah, good. So guys, it's not positive 9. When the minus x goes to the other side, we get minus 9 is x. So it's actually a negative. Okay. And then the other way is, well, not the other way, sorry, where across the y-axis is when x is 0. And again, use your big toe, cover this up. So for y, guys, what'd you get for y when you set x is 0, Mike? Nice, Mike. Negative 9. 3, good. We add the 9 over. 3y is 9. Divide both sides by 3. Y is 3. Good stuff. Now, technically, I did say to write the coordinates. So A, which had an x value of minus 9. So we have minus 9 and 0. And B, which is where it crossed the y-axis, at 3, we have x is 0, y is 3. So don't forget to do that bit as well if they ask for the coordinate. Then finally, it says, given that O is the origin, find the area of triangle OAB. Any recommendations for this one? Any recommendations for this one? Nice, Toby. Pranav, good. Wayne Rooney, let's go. So, Tima, you might need to use that. I'm not too sure. But if you're going to remember anything today, remember this. If it's tricky, draw picky. Okay? Do an axis. Look at that. That's clean right there. It crosses the x-axis at minus 9 and the y-axis at 3. Yes, this is A, this is B, and this is the origin. I have said, find the area of this triangle. Now it's pretty clear. What is the area? Dragon Lord, nearly. You divide by 2, right? FMS, I win. So guys, it's a right angled triangle, alright? It's a right angled triangle. This base length here is 9, not minus 9. And this is 3. Okay? So the area is a half times the base length times the height. Now 9 times 3 is 27, and then 2 is in the denominator. You can leave your answer like this. Okay? Again, my main course students will know this. I say DD. What does DD stand for, especially in non-calculator papers? Unless they ask. Unless they ask. Good, Usman. Don't decimalize. Guys, I'm just giving you as many tips as I can for a non-calculator paper. Yeah, don't decimalize unless they ask you to, because you're just putting yourself at risk of making a mistake. So many students will do 27 over 2 and they'll just be like, I don't know, what's a bad answer? 16 or something. All right. So just don't decimalize. Don't. Okay, TC, you got this. You got this. Tangents to circles. I think somebody asked for this kind of question earlier. We will be doing circle theorems later. Very common in non-calculator papers. Yo, Afreem. What's up, Glenn? In geometry, the tangent to a curve at a given point is the straight line that just touches the curve at that point. All right, so a tangent is a line that meets a curve at one point. And the theorem, when we do circle theorems, is that tangent meets radius at 90 degrees. Rashid, you hope this comes up. I hope so as well. So they could be super basic in the exam and say, look, find the equation of the tangent to the circle x squared plus y squared is 20 at the point 42. What would you recommend everyone does in this situation? What would you recommend? Dark, I agree. Remino, yeah. Don't sub anything in. No, Hattie, you don't cry. Safa, good. What I just tell you guys to do in the last example. Nish, good. When in doubt, draw it out. If it's tricky, draw picky. I should start rapping. So, in normal GCSE, that is a poor axis. Yeah, it's good enough. In normal GCSE, guys, your circle will always have center 0, 0. All right. Oh, that is clean right there. I mean, the axes could have been put in a better place, but that circle is clean. Now respect it. Look at that. Now respect it. Where's the ruler? I don't need a ruler. Okay, that's beautiful, mate. Just out of interest, Ayo, Bassett, don't be a hater. Hater's gonna hate, potato's gonna potato, yeah? What would the radius of this circle be? Cold. It is freezing outside, for real. What is... Nice, Dibala. Guy, good. Nice, guys. Root 20, well done. Remember, the general form of a circle is x squared plus y squared is r squared. Okay? So we're saying r squared is 20. So the radius is root of 20. It's not relevant to this question, but in some questions, guys, it's very relevant. Okay? So just make a note. This is not part of the question. R is root 20. Now that we're on the topic, can you guys simplify that? Nice, Fatima. Holistic. Good stuff. Josh. Hey, yo, Josh, I recognize that second name. Widget Singer. That's Sinhalese, right? My boys were called, my boys from when I was young, they were Widget Singers as well. 2 root 5. So we got root. So we're finding square numbers that go into 20. Yeah, which is 4, aka quattro, times 5. And then root of 4 is 2. And then we have root of 5, just root 5. All right. Not relevant to this question, but it's good for you to just know how to simplify. So I want the tangent at 4, 2. Looks like this. Something like that. What other line would you draw here? Tanishka, nice. We're going to do that right now. Tangent, good. We draw the radius because radius meets tangent at 90 degrees. And as some of you are putting in the chat, you find the grad of the rad. Love that my students are remembering this stuff. Grad of the rad. Okay, the radius. Can you guys tell me what the grad of that rad is? Asad, I'm not Sri Lankan. But there's a big Sri Lankan community in my area. A half, I'm seeing. So how much across and up are we going? We're going 2 up, 4 across. So yeah, 2 over 4, which is a half. All right, what do we do with that? Where am I from? Bognor Regis, mate. Bognor Regis. Thanks, please. Negative recip. Good. So here we have the tangent, guys. Here we have the tangent. We have 90 degrees. We need the negative reciprocal. So the gradient of the tangent is the negative recip. So this is a positive. You make it negative. Reciprocal, you flip the fraction. Shout out J. Cole, which is 2 over 1, just minus 2. Then we can easily work out the equation on the line. So guys, I'll do both ways just because I'm nice. If you use the y minus y1 formula, you would write this. Y minus the y coordinate is the gradient, then x minus the x coordinate. Am I Iranian, Eve? I am not. But Junam. I'm basically fluent in Farsi, innit? Junam. So you have y minus 2 is minus 2x. Minus 2 times minus 4 is plus 8. And then we can just add the 2, right? So you have minus 2x. If you take the minus 2 and you add it over, you get plus 10, right? Now, if you use y equals mx plus c, you would say y equals the gradient x plus c. Then you'd sub in the coordinates, okay? So we have 2, the y coordinate is 2, is minus 2, x is 4 plus c, 2 is minus 8 plus c. You add that over, and there you go, c is 10. So you can rewrite this, y is minus 2x plus 10. Okay. I'm curious though, let me see, Cam, what if someone gets 239 out of 240? It's not looking good. So let's see what the distribution is. I know, because it's only really my students and a select few pupils who use y minus y1. I'm just curious though to see what the majority use. So guys, check out that poll. I'm assuming majority is going to be y equals mx plus c. That's the reason why I'm doing both. But if you did Easter revision with me and you're on my main course, you'll be using the y minus y1. Laurie, what do you mean? How do you do this without this circle? You have to draw it. It's just better to just draw it. Okay. Yeah, so you got 2-3 out of 240 on your November mocks. I'm cooked. The answer is not -2. The answer is what I've underlined. Okay, so as expected, Tanvir, you did Easter revision. What do you mean? You're on my main course, Tanvir. Just a quick reminder, guys, we have cram courses for every subject. Remember, it's all free. So link is in the description if you want to sign up to those. Okay, and that is that. All right, Boogin. Guys, I see we're on 1174 likes. Maybe we could break 1200. Maybe we can break some MyHeadspace records for likes. So I'd appreciate that. Remember to share this link with your mates if you feel like it'll benefit them. Greatly appreciated. Love for the support. Hopefully this is helping you out. Yo, Simrat. Sorry, I can't conduct your lesson today. Coordinates and ratios is another common question that they ask at GCSEs. It says A is the point with coordinates 320, B is the point with coordinates 15, 2. N is the point on the line segment AB, such that AN, NB is 2 to 1. Find the coordinates of N. Right, what would you guys do first? Yes, Pranav. Joe, you're on the right line. Hey, yo, Lucy, at least you're here. That's all that matters. Sean, good. So, guys, what did I say? If it's tricky, draw a picky. When in doubt, draw it out. All right. So A 320. So for these coordinate geometry questions, always draw it out. Okay. What a beautiful straight line. Now, if the ratio of AN and B is 2 to 1, do you think N is closer to A or B? What do you guys think? Ronit saying B. Omar. Man like Don Omar is saying B as well. All right, it is correct. It is closer to B. A, B, C. Easy is 3, 2, 1. So it's saying AN is 2 parts. It is the longer side. So it must be over here. Yeah, where this is 2 parts, this is 1 part. All right, so we need to locate N. What would you guys work out next? Thanks, Harpreet. Thanks for your contribution. Yes, Carty, my guy. Beth, what was that? 812. 812. Oh, that might be your answer. Technically the gradient, yeah. Okay. Yo, Unix, what's up? So working out how to go from this to this. Now, what do you notice in terms of the way I've drawn this? If I was to do it on a coordinate axis, have I drawn it correctly? Just out of interest, if I was using a coordinate axis, like sketching it properly on an axis, is it correct? No. But guys, it's not a big deal. So technically it's sloping downwards because of this 2. Now, if you guys want to, you can very quickly just redraw it, yeah, and have it sloping downwards, yeah? So in general, I just do it upwards, and you can just say that it's minus. But once you realize that it's not always an upward sloping, you can just do it downwards. Yo, Galloway in the chat, that's crazy. Let's do it again. So we have A, which is at 320, and then do it down. So basically what I'm suggesting here, guys, is it's okay to draw it once and realize that you did it well, it really is the other way around, okay? So to go from A to B, we're going across and down. How much across are we going? Thanks, Hasham. So to go across, other way around, Josh, but yes, Ali, good stuff. So 12, and then we're going down from 20 to 2, 18, all right? Then what would you guys do next? Bengalis on top. Get out of it. What would you guys... So Lucy divide by 3, yes. But I would do... So not just divide by 3. What else? So you wouldn't do Pythagoras. We're not Pythagoras here. Good, Lucy. Times by 2. So guys, we want to go from A. Look at the way we've done the arrows. We've done it from A, haven't we? And we want to go to N. Yeah? So we're basically using similar triangles, but we're saying, look, the red is 2/3 of the distances that I found before. So we need to do 2/3 of 12 and 2/3 of 18. What is that? What's 2/3 of 12? Geez, Blaise Okoro, aka Blaise Pascal, aka one of the greatest mathematicians of all time. Timothy saying ocho. Man like Galois theory saying ocho. 3 goes into 12 4 times. Yeah, cross cancellation. 2 lots of 4 is ocho. What's 2/3 of 18? Nice one, Musa. I'm seeing 12. 3 goes into 18 6 times. 2 lots of 6 is 12, mate. Okay, so we are going 8 this way and 12 down. So guys, starting at A, if you go 8 across and 12 down, where would you be? What would that coordinate be? Don't worry, Max, I'll do that later. Hannah, the 12 is here. That's what we did 2/3 of. Patricia, good, 11. So we're at 3. Bruh. We're at 3. and we're going 8 across, so we're going to be adding 8. Then 20, we're going down 12, so we're going to be minusing 12. So there you go, 11, 8. Okay. Another question that could be 5 marks in the exam. Okay, sorry, I realize I still got this poll. I know some of you guys are communicating on tiny screens. Yo, what's up? Talk internet. Nobody can compete with my screen though. Just I could do YouTube from this. Yo, what's up, Mike? Nobody's got my better phone than me. Generation better. Galois, Neil, Euler or Gauss? That's a tough one, but I'd probably say Euler. I think what Euler's done with maths is like nuts. All right, adding and subtracting algebraic fractions. When we add fractions, guys, what should we be looking for? Hey, yo, Jaden, you're violent. Just because I have this phone does not make me unk status. Nico, it was minus 18. Oh, wait. Yeah, it was minus 18 because we're going down, wasn't it? Same denominator, good. What would your common denominator be here? What would be your common denominator? XY, nice. So guys, X does not go into Y and Y does not go into X. It's just like if I had 1/3 and 1/5. Your common denominator would be 15, right? Because 3 does not go into 5 and 5 does not go into 3. So we choose 3 times 5 to be your common denominator. So here you multiply them together to get XY. Okay? So in the first fraction, to make that common denominator, we just need to times top and bottom by Y. Yeah, 1 times Y is Y. And then on the second fraction, we would have to times it by X. Yeah, to make it YX or XY. 2 times X is 2X. And that is the answer. Now respect it. Now with part B, what would you guys do first? Yikes. Barnet FC. All day. All day. Hey, Ozara, get out of here, man. Thanks, Jason. Yes, Matty. So, guys, before you do anything, you do brackets. You protect anything with more than one term. 4 is a single term. 2 is a single term. 2x minus 1 is 2 terms. The 2x and the 1. Bracket. And this one, bracket. Once we've done that, what is our common denominator? Nice, S. Trust me, Izzy. Respect the bracket. No, Farah. Hopefully you heal soon, but still on the grind. Thank you guys for the 1,300 likes. Appreciate the love. Hopefully you are gaining something out of this, which is good. So, guys, just like the one above, 2x minus 1 does not go into x plus 3. X plus 3 does not go into 2x plus 1. So we take one of each. Okay. Thank you, guys. Now, in the first fraction, what do we need to times top and bottom by? So in the first fraction, what do we need to times top and bottom by? Hey, yo, BX. What kind of question is that? So yeah, guys, the first fraction is missing the x plus 3. So we have to times top and bottom by x plus 3. So we have 4x plus 3. And then on the second fraction, obviously, we need to times by 2x minus 1. Okay, so we don't forget, guys, there is a minus there. What would you guys do next? Leave it like this? Dzień dobry, dzień dobry. Yeah, you need to simplify, guys. So you need to expand and simplify. Now, something really nice happens here. Obviously, I calculated this before. What does the numerator simplify to? Nice Arc. Man like Arc data centers, let's go. Hypes says 14. Wagyu said 14. Well, it says Whack Y7865, but you're now Wagyu. So you have 4x, 4 eggs, plus 12. Minus 4x. Most common mistake, guys, is saying minus 2. Okay? Guys, I don't want to see you guys saying that minus 2 times minus 1 is minus 2. Yeah? It is plus 2. Plus 2. ¿Qué pasa? And then we can see that the 4x's do cancel. Boom. So the numerator is actually 14, not 10. Man like Wagyu beef, let's go. I like my steak medium rare. Okay. Arc. So it's a good point actually you're making here. Over here, guys, why are we not allowed to cancel an x plus 3 or 2x minus 1? Because students do that. Why are you not allowed to cancel anything? S, not that it's one term, it's the other way. It's the other thing that we're saying. Good, Sharia. The negative sign. Guys, that negative sign here is the reason why we cannot cancel. That negative sign means that there is 2 terms here. And with 2 terms on the numerator, you're not allowed to cancel anything. All right? So good point. And a question before was, with the denominator, guys, do you need to expand it? Yes or no? Good, Pamela. Wagyu beef. Good. Good, guys. No. Only if they ask. Good, Hastor. Guys, if they ask you to expand it, all right? But if they don't ask you, you don't need to do it, all right? Okay. Micro guy, I'm not Scottish. Although I do have a Scottish fridge magnet. I do want to go to Scotland one day to have their deep fried Mars bar. Another common question, guys, is the 4 operations and algebraic fractions. So basically BIDMAS and algebraic fractions. So show that 6 plus x plus 5 divided by all of this simplifies to this. What would you guys do first? Come on, how do you guys not know about the deep fried Mars bars? KT, good. We need to do the KFC, meaning you're implying that we need to do what's inside the briquette first. Okay? So think about BIDMAS, which, guys, is very likely to come up tomorrow in terms of like, I don't know, something basic like this. All right? That kind of question most likely going to come up tomorrow, but I ain't doing all that easy stuff. So, think about BIDMAS, we need to do the briquettes first, which means x plus 5 divided by x squared plus 3x minus 10 over x minus 1. What would you guys do next? Yeah, yo, Jamie. So a good thing to do is to factorize and for sure KFC. Okay? So we don't want to divide them. We want to multiply them. All right? So we have x plus 5 times. Now, we're obviously going to flip the fraction. Can you all factorize this? So we are going to be factorizing so that things cancel, right? Let's all factorize that. Lulzim, what does I stands for index, so powers. Yo, Roshzino. Okay, good. So, oi oi. So x times x gives you x squared. For 10, we're using 5 and 2. To make plus 3, I need plus 5 minus 2. And then we have x minus 1. But guys, remember, brick it whenever there's more than one term. And then what do you notice happens? Yo, Daddy Pig. Welcome. Toby, because we did KFC. Keep, flip, change. We kept, we flipped, and changed this. Alex, good stuff. Cancel. Andrew, that's it. Yeah. What's on the top cancels with what's on the bottom. X plus 5 divided by X plus 5 is 1, so we can just ignore it. So we're left with X minus 1 over X minus 2. And that is what this bracket simplifies to. But don't forget, guys, we have this 6 plus. 6 plus X minus 1 over X minus 2. What would you guys do next? Yes, God's child. Let's go. Sapper, what do you mean by that? Yes, Quavar will do. Don't worry, I got you guys. Howell, I think that's your name. But yes, good. So guys, we should be writing as 6 over 1. Good, Jay. Michelle, good. We need to do a common denominator. So that's 6. We can write as 6 over 1. What should we be doing? Jacob, no, they can't. So 2 denominators can't cancel each other out. Protect. So guys, before we do anything, we should be putting a bracket around more than one term. Now we're going to say common denominator. What is the common denominator going to be? LES, exactly. FPY, I can't lie. If you write more than 4 words, I probably won't end up seeing it because the chat's too quick. Good, Shannon. Good. So X minus 2. Yeah, you're taking one of each unique denominator. So for the first fraction, we need to multiply top and bottom by X minus 2. Okay. So we have 6, X minus 2. And then we have plus X minus 1. So obviously you need to simplify the numerator. What does that give you? What does that give you? Tom Wilde. Nice. Isn't that an author? Or am I bugging? Maybe I need to attend one of Louis' lessons and Alex. Alright, so we got 6x. I'm bugging. Neil reads books. I heard you guys been reading Peppa Pig for your GCSE exams. How times change, man. How times change. Twisted Aims. You're bugging. Oscar Wilde, Eve. Oh, okay, okay. How times change. How times change. I heard you guys reading Peppa Pig and Coco Melon for your English literature exam. So you're minus 13 over x minus 2. There we go. Another cheeky 5-mark question. Amber Chloe, I know it's true, man. Another 5-mark question. Okay. Yes, Wayne Rooney, we will. Okay. Yes, Nimbra, I will. There's a workbook, guys. You can see what we're covering today. So, circle theorems. A lot of you guys asked for this. So, I have summarized all the key ones. If you are doing IGCSE, I mean, all IGCSE papers are calculator, so most likely you wouldn't be here. But there is one more IGCSE circle theorem that GCSE lot don't need to know. But these are all the normal GCSE circle theorems you need to know in the next couple. The first two are not circle theorems, but we know angles in a quadrilateral add up to 360, and that base angles of an isosceles triangle are equal. We use them all the time in circle theorems. But the first circle theorem we need to know is that tangent meets radius at 90 degrees. We discovered that one earlier. The next one is angles in a semicircle are 90 degrees. So you need to know the wording, all right? The wording is important, mucho importante, for the exam because they'll ask you for reasons, all right? Teletubbies. That's crazy. I didn't think you guys knew about Teletubbies. The next one you need to know, guys, is the arrowheads. So angle at the center is twice angle at the circumference. Number 4, angles in the same segment are equal. Yeah, so angles in the same segment. So if you have 2 points, A and B, and you draw lines from A and B to the circumference, they all produce the same angle, and in this case, it would be y. Okay? Then the last one, well, not the last one, there are more, is opposite angles of a cyclic quadrilateral add up to 180. Guys, does this rule apply to this quadratic? Yes or no? I mean, quadrilateral, sorry. Does it apply? Because students make this mistake all the time. Good. The answer is no, because it's not cyclic. Guys, it has to be inscribed in a circle where all the points on the quadrilateral are on the circumference. How about this one? Does the rule apply to this? The answer is no. Guys, every single point needs to be on the circumference. Okay? No. Only this one, alright? Make a note. The next one, very common, is that the lengths of the tangent from a point to a circle are equal. So these two lengths are always equal to each other. Now this theorem, most of the time, gets combined with theorem 1, which is tangent meets radius at 90 degrees. Hopefully you guys have seen this before, alright? If you've not seen this before, you've not done enough practice, but it's all good. We'll do a bit of practice as well, alright? The next circle theorem is that the radius is of constant length. That's obvious, alright? And this will always end up having a isosceles triangle or an isosceles triangle. So you just need to mention these in the exam. All right, so you guys can flick back and forth to the various circle theorems. The last one, probably a fan favorite, is the alternate segment theorem. Now, it's not complete. I'm going to be completing it for you. The alternate segment theorem, aka AST, is all about the angle wedge between a tangent and a chord. Okay, so the angle between a chord and a tangent is equal to the angle subtended from the chord to any other point. So guys, the alternate segment theorem always combines with this one. Okay, and I'll show you how. So from these 2 points, the chord, if you draw lines to anywhere on the circumference, it will be the same angle theta. You can draw anywhere. Guys, draw as many as you want. Don't mess up your diagram. But can you see how it combines with the other theorem? All of these would be theta. Twisted, what is a chord? A chord is just a line that connects any 2 points on the circumference of a circle. Can anyone tell me what is a special type of chord? The most specific type of chord? Abdul, subtended means these lines that I've just drawn. So subtended is this. This is what subtended is. Good. S. AO. Good. The diameter. So guys, the diameter is a chord. It's just a chord that goes right through the center. It's the longest chord in a circle. So these are all chords. Yeah, these are all chords. It's just the diameter is a special type of chord. All right? George, violin chord. Hey, yo, for real, it kind of looks like that. All right. So, we will take a 5-minute break in a sec, guys, once I've covered the circle theorem stuff. So find giving reasons for your answers. The angles BFE. Where's that? BFE, this one. All right. Who can tell me what that is and why? Yo, George. Come on, George. Shout out of Mice and Men. Although I don't think you guys study of Mice and Men anymore. 132 I'm seeing. Liam, good. Because we're using what? Aki, you don't know why, but you thought I was Italian. I am partially Italian. I got my Italian passport. I got it last Friday. Let's go. Dragon Lord, good. Cyclic quadrilateral. So guys, we're looking here. So look, can you see all these 4 points? So I picked questions where we utilize loads of different theorems in one, innit? So BFE, the BFE is 180, take away 48, which is 132. So this one is op angles in cyclic quad sum to 180. All right. The more you write it, the better, or easier it'll be to remember. Okay. What about the angle Bank of England? BOE. Where's that? But BOE, this one. All right, guys. What's that one? BOE. Chili potato wood. Triangle EDBB isosceles. EDB. Unfortunately not. Chili. Good question. If I did this, then it would be isosceles. But without that, it is not isosceles. So 96 is correct because angle at the center is double. Thanks, Vich. So we're looking at this arrowhead. Yeah. So this angle here is double this one. So we've got the Bank of England is 2 lots of 48 degrees, which is 96 degrees. Angle at center is W. Angle at circumference. All right, ¿qué pasa? Next one. OEB. 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 What's the OEB? OEB. Where's that? Ah, this. All right, what are we thinking about that one? Good stuff, mate. Good stuff. This is looking like a cheeky isosceles triangle. All right? Because OE and OB are the radii. So we're going to do 180, take away 96, which is going to be the sum of these two. But then because it's isosceles, we're going to divide by 2. Good stuff. 180 minus 96 is 84. So yeah, 42 degrees. Yeah. So we're going to say, if they ask for reasons, guys, we're going to say OE equals OB. OB, they're the radii. Therefore, triangle OEB is isosceles. Okay. And then finally, part D, we've got Arbe. Arbe. What's Arbe? Arbe is this one. Okay, what's Arbe? Junwoo saying 48. Abe Lincoln. Now, I was thinking Arbe, which is dad in Somalian. Arbe and Hoya. 48, good. So, if I was to just show you guys a bit more clearly without all my annotations, is we have got the alternate segment theorem, good. We have an angle between a tangent and a chord. And then from that chord, do I speak Urdu? I do. Hanji. From this point, we go to the circumference. 48. AST. In the exam, obviously, you put the full thing. Okay? I'm not Asad. All right, next one. How many of you guys have seen the proof of the angle at the center is double the circumference? I think after this, we'll take a 5-minute break. Yeah, okay. Just make sure we know how to do this one. Calante, what's up, dude? Aki, how many languages do I know? Too many. This is what happens when you grow up in the suburbs of London. Okay, so some of you have seen it. So I'm asking you to prove that the angle at the center is double this one. Yeah, so I'm trying to prove to you that that angle is double this one. Who knows what we need to draw first? What do we need to draw first? What's up, Jarmis? Ivan? Draw X and Y? Where? Okay, good, guys. We have to split. It's looking good. We draw a line from O to B. All right? And then we label these two angles as X and Y. Okay? So we're going to let A, B, O, A, B, O equal eggs. And O, B, C. I love this proof. Because once you define it like this, the rest of the proof falls into place really nicely. What do we say next? Da Vinci, the alternate segment theorem, AST. Charlotte, good. We will be doing the 180 minus, but first we need to define the other ones. So yeah, guys, good. We have an isosceles triangle. We have an isosceles triangle in both of them. So this is going to be X and this is going to be Y, isn't it? All right. So we just need to state OA equals OB equals OC because they are the radii, that's plural for radius. Therefore, triangle OAB and triangle OBC are isosceles. All right. Therefore, we can say this angle, which is OAB, OAB, is eggs, and OCB is Y. Okay, now that we've defined those, what do we do next? Once we've done that. Farhad, the three dots means therefore. Therefore. Lara, good. So we're going to do 180 minus 2x. So we're going to do angles in a triangle. And this will be 180 minus 2y. So we're going to say therefore AOB is 180 minus 2x. And what would the other one be? COB, corn on the cob, is 180 minus 2y. Then what do we do? Yeah, guys, all the notation I'm using, you can use in the exam. I'm surprised your teachers haven't shown you what the therefore symbol is. It's not looking good. Ivan, good. Megan, why are X and Y not the same? So we're proving it generally. So it could be possible that X and Y are the same. But generally, they're not going to be the same. So we're doing that, the most general version of this. So yeah, now we have to do 360, subtract the sum. So 180 minus 2x and 180 minus 2y. What does that all simplify to? What does that simplify to? Yo, Yusuf. Yo, Baguette. So here we have 360. Nimra, good. 180 plus 180 is 360 minus 2x minus 2y. When you expand that, guys, you get 360 minus 360 plus 2x plus 2y. And there you go. My laptop wants me to start gaming again. It's not looking good. Now, guys, what do you notice about 2x plus 2y? Yasaru, good stuff. Ronit, can you also prove with joining AC and AST? What's AST? I'm not sure what AST is. Factorize it. It's double x plus y. Good. So this angle here is AOC. Yeah, AOC. Now, AOC is 2 lots of x plus y, which is this angle. That's x plus y. So AOC is 2 lots of ABC. And that's proved. Okay. Now, guys, no, you can't use alternate segment theorem to prove this one. This proof, guys, is the exact same. Oh, that is a clean circle. It's the exact same as this one. Okay. So it's the exact same. All right, exact same. Okay, L circle. Ayo, don't hate on my circle. That's claim right there. Mimi, when did I do proof in the main course? Main course students, can you direct um Mimi to when we did all the circle theorem proofs? All right, guys. So we'll take a 5-minute break. We'll start again at 7:20. Feel free. Oh, guys, special news. So remember, there is other cram courses. Make sure you sign up. But I told you guys that I was going to give you some more free stuff. So all you guys need to do is scan the QR code to get some last minute revision resources, not just for maths, it's for all the subjects. Okay. So just scan that code to cop your revision resources. Like I said, guys, it's all free. We're just trying to give as much as we can to you guys to smash your exams. Sadly, too late, mate. You're welcome. You're welcome. I got you guys, man. I got you guys. Let's see if we can hit 1,500 likes. Appreciate the love. 10 minutes. Saded. What is this? Your exam's tomorrow, mate. You need to chill out. I got you, George. Big up you, Nathan. Fatima, link? There is no link. Just scan the QR code, mate. Unfortunately, I can't scan it because I got a... Can try and use my Hokia phone, but it doesn't seem to work. Actually, I actually don't think it does work. Thanks for the 1,500 likes, guys. I appreciate it. I can play Snake on this. You guys are proper Utes, Peppa Pig watchers. Do you guys even know what this is? Yeah, yeah, you guys don't know about Snake. Oh, I missed it. It's hard to do it like backwards. Oh no. Oh! You see that? Now respect it. Ian, these are I'm going through some of the most challenging topics for non-calculator papers. Ayo, Inni, you got this. Adam, you got a lightsaber off Timu for a 10 for a tenner. I don't know. You have to show me. Yo, Cider. I will be doing congruency, Sai. Guys, if you have the workbook, you'll be seeing what I'm doing today. Alfie, am I gonna do maths? That's the best question of the day. I'm very happy that my Timu laptop has been holding up so far. It's looking good, Mike. It's looking good. Sana, I don't do one-to-one tutoring, but I do group tuition like this in this form. It's good fun. It's good fun. Yes, let you see what my Timu laptop. I can take a photo of it. You can see the quality of my phone. All right. Can you see it? That's my laptop. You can see the good quality. Yo, Fine Piece, what's up? Of course. Of course. One of my year fives are in the class. That's a W. Tanisha, unfortunately, won't have time for Kahoot. If you guys join the main course next year in year 12, you'll probably have time to do Kahoot with Nick. Gallo, unfortunately, there'll be no further maths GCSE lives. But I do have some YouTube videos with further maths GCSE. Floss half Indian, yeah. Kemcho. Mohammed, next year the further maths courses for A level will be Nick. You've been taught by Nick. I'll be focusing on the normal maths. That's 20 past. PT, you can flick back. That's subjective about whether the earlier topics were easier or not. Am I good you? Half. Kemcho. Nah, can you do proof of the right angle triangle segment thingy? What's that? Do you mean the circle theorem? It's the exact same. It's the exact same. So express the following in the form x plus p squared plus q by completing the square. All right, guys, let's see if you know how to complete the square. It's all good time. You'll be able to, in time, you'll be able to get a good night's sleep. Thanks, Chris. Makala got x plus 7 squared minus 39. SMEPL. How do I prove I got 240 out of 240? Well, the first thing is we need to see that you're on our main course. So you're on my main GCSE course. I only just take a picture of your script. So whoever on my main course does get 240 out of 240, they'll have the opportunity to give me a buzz cut. Chili potato again, the same maca. So, to complete the square, very simple, guys. You open a squared bracket. Yeah, you put x, because you have still the x squared, right? You half the coefficient of x, so you divide it by 2, which would be plus 7. Then you subtract this number squared. 7 squared is 49. And then the number here just stays the same. It's that simple. So we have x plus 7 squared minus 39. Okay? Now with part B, what would you guys say for part B? Nice one, Mike. What would you do for... So, Sappho, we have to be careful when saying dividing by 3. Guys, why are we not allowed to divide by 3? Because it's very common for students to do this. Why can we not divide by 3? Exactly, young Salen. Good, Dev. It does not equal 0. Guys, if a function or expression does not equal 0, you can't just divide by numbers. Okay? So, we have to factorize. Now, when we factorize the 3, does it need to be from all terms, the first 2? Does it not matter? Which one would you guys do? Dio, you're violin. Just the first 2. So there might be a case, guys, I could be a bit annoying here and change that to 5. Yeah? If I change that to 5, it actually doesn't change anything. Because you're still just factorizing out 3 from the first 2 terms only. Okay? So, let's do that, mate. We get 3. 3. Yo, nicer. Hopefully you're not missing me too much in our cancelled A-level lesson. So we factorize out 3, guys, from the first 2 terms. We get x squared plus, what would it be, 5x. Close the bracket, minus 3. Okay? Mummy Pig, yo, the pre-recorded lesson for year 13 is... Yeah, because Mummy Pig, I need to record it. Don't worry, it'll come out end of this week. So, to complete the square, guys, we're going to do it on what's inside the squared bracket. So we have 3, square bracket, open up a squared bracket. So we have x. Now we have to half the coefficient of x. How would you guys half this? What would you guys write down? What would you guys write down? Good Safa. Good Archie. Cool name. If you watch Mobland. 5/2. Good. Guys, what I tell you, in non-calculator papers, you keep as a fraction. DD, don't decimalize. Alright? And then you subtract this number squared. It's much easier to square a fraction rather than a decimal. So guys, when you square 5/2, what'd you get? Mootly boy. Fractions are your friend. I like it. Good. Guys, squaring this, you square the top, 25. You square the bottom, 4. Okay? So much easier than saying, what's 2.5 times 2.5? Okay? And then we have the minus 3. Now, what do we need to do next? Good stuff, Kenley. Wow, friendly fractions. Nice. Yo, Krish, we sim. Joseph. Expand the bracket. Okay. Now, Joe, when we multiply in this 3, guys, does it go inside the bracket or do we keep on the outside? Good, it stays on the outside. Guys, the bracket is being protected. There's a squared there, yeah? So it's 3 lots of x plus 5 over 2. Leave what's on the inside on the inside. Then you have to do 3 times minus 25 over 4. What is that? You could write it in another place. 3 times 25 over 4. What does that simplify to? Yep, Zach. Wayne Rooney. Good stuff. You're welcome, Jamie White. Leo, good. So guys, 3 times 25. When you multiply, it multiplies the numerators, right? So 3 times 25 is 75. Ooh, it's minus. Is minus. Then don't forget, guys, we still have that minus 3. Remember, this is non-calculator. So we need to subtract 3 from 75 over 4. What would you do with that? Hey, Farage. Minus. Good, Gawa. So we need to make it over 4. Go run it. George, exactly. We rise 3 over 1. Which over 4 would be, Abbas, exactly, times top and bottom by quattro. Okay. I'll just, we're doing this, which I'll just write again. Usually I'll just annotate the fraction, but it's all good. It's all good. So what does that simplify to? Yo, Amber G. So many OGs here. Farage, we won't learn this in year 8, no. Minus 87 over 4. Alright. Let's go. Let's go. Okay, guys, remember you're doing minus 75 minus 12, not minus 75 plus 12. Alright? Okay. Functions. Funzione, funzione, oh, oh, oh. So there's only so much I can do for functions today. But remember, guys, I've got tons of YouTube videos on functions. So make sure you watch my YouTube videos. Free, obviously. And make sure you're subscribed for, obviously, more maths videos. How do you find inverse functions? Good, Georgie Pig. Thanks, mate. Safa, you will get a 9 in Spanish because of me. Bonjour, bonjour. So we have y equals x over 2x minus 1. So find the inverse, guys. The whole point about inverse functions is a function takes you from your x values to your y values. The inverse function does it the other way around. So that's why you're swapping the x and the y. Yeah, you're welcome. Great, great, great Spanish, mate. So we have x is y over 2y minus 1. Murkmanav. Shout out to anyone who knows what that means. Murkmanav. What do we do next? We have to rearrange for y. You're welcome, intelligent melon. Protect. Good. Sanjid. Good. After that, we need to multiply through by the denominator. Okay? So we take the denominator and we're going to multiply through by it. Okay? So we're multiplying both sides by the denominator because we do not like fractions. Okay, so we have x lots of 2y minus 1 is y. Okay, then we expand. Okay, so we have 2xy, and then we have x times minus 1, which is minus x, is y. Now, would you guys collect all the y's on the left side or the right side? Which way would you guys do it? To the left, Beyonce, or to the right, Ronan Keaton? Yo, Zach, please. Lupo, Dr. Lupo is saying left. It's not looking good for Dr. Lupo. Yo, Taj. Definitely left. Definitely Beyonce out here. Because, guys, you want to keep as many terms positive as possible. If you move the 2xy here, you're going to get minus x, which already is a red flag, is y minus 2xy. Okay? By bringing the y over here, it becomes minus y. But at the same time, the minus x can come to this side to become plus x. Okay? So we have 2xy. Dara, so we don't need to make it equal 0 because we're not solving anything. Okay? So the positive y, when we bring over to the left side, is minus y. And the minus x, when we bring to the other side, is plus x. Then what do we do next? Nice S. Jerry, good stuff. We factorize out the y. We get 2x minus 1 is eggs. And then we divide by the bracket. Do you guys notice anything? What do you guys notice? Matty, the mouse. Good. It is the exact same as f of x. Guys, this is a special function. This is why I'm doing it with you today. Do you guys know what it is known as when a function is equal to its inverse? Nice, Bob. Mohammed, good. My main course students will 100% know this. Yes, it's known as a self-inverse, good Sana. So I need you guys to write this down. When f of x equals f minus 1 x, it is known, they can ask you this in the exam, as a self-inverse function. Nick, good word there. Piecewise function is something else. A piecewise function is one function for a certain part of the graph and another function for another. They kind of look like this. It could look like something like this, where you have one function this way and another function that way, but we don't do that at GCSE. I don't know if you guys do it in further maths. You might do. Do you guys do piecewise functions in further maths? Can't remember. Oh, Junwoo, you do. Oh, okay. Nice, Monty. Interessante. All right. All right, so here's another interesting functions question. Composite function. So we have f is the function such that f of x is 2x minus 3. G is the function such that g of x is x squared minus 5. Solve gfk is minus 1. Okay, what would you guys do first here? Maybe Faraj. Amber Chloe. F of k first. Good. So guys, we always work backwards here. Yeah. So we're taking k and we're subbing it into f. Yeah. And then we're going to take that and sub into g. So we're taking k, subbing into f, and then we're going to sub that into g. So guys, if f of x is 2x minus 3, what is f of k? What would f of k be? Thanks, STL. No, Zozo. So we're solving what? So the question's basically saying, what value of k, what does this number need to be so that when you sub it into f and then sub that number into g, you are left with minus 1. Okay? So that's what the question is asking us. What value of k do you need to sub into f and then sub into g to get minus 1? So f of k, guys, means wherever you see x, you are going to replace it with k. You actual lemon. Good stuff. So wherever I see x, I am replacing it with k. So 2k minus 3. All right? And that is what we are subbing into g. Okay? So that f of k, which is 2x minus 3, we are substituting that into g. So we're doing g of 2k minus 3. Can you guys tell me what 2k minus 3 is? What is 2k, g of 2k minus 3? Not x, not minus. So it does equal minus 1, but I want the expression for this. Thanks, Sanjid. Hasta, k minus 2, k squared minus 5. So what we're doing here, guys, is we're not doing g of k. So g of k would be k squared minus 5. But that's not what we're doing. We're doing g of 2k minus 3. Okay? So let me show you guys. Iman, good stuff. So look at this. We have g of something is something squared minus 5. I am replacing it. Good hyper. We just had to put the squared in a different place. I am replacing x with 2k minus 3. Okay? So, wherever I see x, I'm replacing it with 2k minus 3. You have to make sure you use a bracket, then minus 5. Can you see, guys? Look at the color code. Look at the color code. And is that is minus 1. What would you guys do next? Robert, I'm helping myself go bold if I think about it. The game's the game, man. I'd rather you guys get good grades and I go bold for it. Good, Sanjid. Now, Amonic, you can do that. And Riley, yes, you can just expand, but there is an easier way of doing this. Angad, good. Guys, we're solving for one unknown. K is in one place. Why do you need to expand? Why do you need to expand? You can just solve it like this. We can rearrange for K. Yeah, we can add 5 to both sides. This is just a completed squared form. Okay, so we have 2k minus 3 squared is 4. Then what do we do? Nice one, Pumpkinhead. Root it, good. Now when we root, what do we need to be careful of? Vivan, basically nothing, if I'll be honest. So when we square root Monty, good, we get plus or minus. So the way I would write it, guys, is I'll see this 2k minus 3 is 2 or minus 2. That's a clever way of representing this one. Then we're going to add 3 everywhere. So we get 2k is 2 plus 3, which is 5, minus 2 plus 3, which is 1. And then finally, Mahek, good, we divide by 2. Don't decimalize, man. So there you go. K is 5 over 2, or K is half. Nice, Tyranny. DD, don't decimalize. Okay? Don't decimalize. Barrel, what if it says 2GFK is minus 1? 2GFK. So if there was a 2 here, if there was a big 2 here, then there'd be a big 2 here. You'll be doing 2 lots of all of this. Yeah. And one thing you could do as well, if you wanted to, is you could divide by 2 on both sides if you want. But yeah, otherwise you're just doubling everything over here. Okay. All right. Apia, you got 1 and 2. Just follow my steps and see where you went wrong. Okay. Right. Some of you guys were asking about transformations. Don't worry, I got you guys. Now, transformations of functions links heavily with sketching quadratics. Okay. So complete the table to come up with general rules on how modifications inside and outside of f of something will affect our graphs. Now, guys, if you see a change inside f of x, like this, which axes does that affect? Which axes does that affect? Yo, Samlock. X. Guys, it literally says X plus 3. Anything inside the bracket is affecting the X-axis. Anything outside is saying 4 times F. Think of F as being your Y value, right? 4 times F is affecting the Y-axis if it's an outside thing. Now, if it's affecting the X-axis, does it do as it says or does it do the opposite? Is it an ops or is it a says, I guess? Good, it's an ops. So guys, anything that affects the X-axis does the opposite of what it says. All right? Oopsie. And whatever's affecting the Y does as it says. Okay? So describe the transformations of f of x for f of x plus 3. What transformation is that, guys? What is that doing to the graph? Yo, Proddy. I don't have ops. 3 left. Okay, so if you think about your x-axis, guys, yeah, think you have like numbers. This says x plus 3, so it looks like it's saying 1, 2, 3. But remember, guys, we're doing the ops. So actually going left. Okay. Now, if you guys say left 3, you will not get the marks. Why? If you say 3 left, you will not get the marks. Why? Good, Sanjid. Good, Dawn. Good, guys. When I say transformation, you need to describe if it's a translation, rotation, reflection, or enlargement. Okay. So, Mariam, yeah, we need the vector. So when we're moving left, that is a translation. Okay, it's a translation by the vector. This is how you'd word it. Then into a column vector. It's affecting the x-axis, so we're changing the top number, which is -3. And then nothing's happening to the y. So what's part B doing? What's part B saying? No, Galo, I don't know about the magic boat. So it's an enlargement. And yes, in the y-axis. So guys, 4 is outside. So it's affecting the y, and it does as it says. We're multiplying the y values by 4, which is an enlargement. Okay. So when we say enlargements, what else do we need to say? We need to say scale factor good. And in general, guys, when we say enlargements, it's usually to the x and y. So we need to specifically say it's to the y-axis only. Okay. So you'd say like this. Enlargement by a scale factor of 4 parallel to the y-axis. That's the best way of saying this one. Okay, so an enlargement by a scale factor of 4 parallel to the y-axis. And finally, guys, part 2. What would you say for that one? Avery, it depends on the graph. Good question, Megan. I'll ask that question after this one. Up by 3, so we would say what? Jaheim, because you're multiplying only the y values by 4, not the x. That's why we say parallel to the y-axis. Nimra, good. Miguel, good. What's the vector? Good, is he? So guys, Zara broccoli. Nice. Chicken, broccoli, and rice. That's all we should be eating, mate. Breakfast, lunch, and dinner. So there's a translation. Translation by the vector. And because we're going up 3, we're doing nothing on the x-axis. And we're going 3 up. Now, somebody asked, guys, what happens if it was this f of 4x? What would you guys say for that? How would you describe that one? Not stretched down. That doesn't mean anything. I know what you mean, though. Shrinked. I get it. You shrinked it. So you're dividing the x values by 4. So if you're dividing by 4, it's an enlargement, right? Now, guys, when it comes to enlargements, you need to say multiplication. So you don't say an enlargement by dividing by 4. You're saying an enlargement by a scale factor of what? Moonlight, good. Dancing in the moonlight, everybody. So we're saying a quarter, yes. So this would be an enlargement by a scale factor of a quarter parallel to the x-axis. Nice. Let's go. Okay, next one. Farah, you just combine A and B. You just say them separately. But at GCSE, they wouldn't ask you to do two transformations. They would at A level, though. Okay, Jono, no, because the scale factor is not -4. If it was -4, that would be a reflection as well. Okay. Now, sketching quadratics. If you've been watching my videos for long enough, you'll know that sketching quadratics, especially when it comes to completing the square and finding the turning points, can be worth 6 marks. I've also seen in EDEXCEL having a 7-mark question to do with this. Okay. Now, there's only 4 things we need to consider when sketching quadratics. The first one is the turning point. The turning point by completing the square. Then we have the roots. Now, the roots, guys, is when y is 0. Yeah, to find where anything crosses the x-axis, you make y equals 0. We have the y-intercept, which is when x is 0. And then we have the shape. All right? The shape meaning, is it a positive x squared or a negative x squared? So, let's do an example. Sketch the graph of y equals x squared minus 8x plus 5, including the coordinates of the turning point. Now, with all quadratics, guys, you should always be able to tell me the y-intercept first. Where does that quadratic cross the y-axis? Fatima, don't spread misinformation. 7 markers do exist. 5. You always look at the constant at the end. You know, like y equals mx plus c. You look at the constant at the end. That will tell you where it crosses the y-axis. Okay? So, when x is 0, y is 5. Okay? Because you're setting x to be 0, you're just left with 5. Okay, so that's our y-intercept, which is 0, 5. At least you got a mark there. Now, the next thing is, what do you guys think we should do next? Find the roots or the turning point? What do you think would be a good thing to do next? Okay, guys, we always, with these questions, do the turning point next. Now, the reason for that is, what do you even notice about this quadratic in terms of roots? What do you notice? Let's see if you notice something about this. Good, S. It doesn't even factorize. Guys, finding the roots here is going to be really hard. Yeah? So you might as well just complete the square and figure out the roots from there. This doesn't factorize, so why waste your time? Okay, good, Gemma. So let's complete the square. Can you guys complete the square on this? What does it give you? And then Chloe, yeah, we could find the roots easily from the turning point, and especially because it's non-calculator, it's just better to use completing the square instead of the quadratic formula. Okay, so I'm seeing 4 minus 11. You guys are telling me the turning point rather than actually completing the square, but it's all good. So we have x. We half the coefficient is -4. We subtract this number squared. 4 squared is 16. Then we add 5. Alrighty then. So we have y is x minus 4 squared. Minus 16 plus 5 is minus 11. So from here, what's the turning point? It is 4 minus 11. Good stuff. It is always the negative of this number, which is 4. And that's to do with the transformations, because you're taking the graph and you're moving it 4 to the right. And then you're moving it 11 down. Okay? Now from here, guys, we start drawing the quadratic, because then we'll know if it has roots. So we have 0, 5 over here. And 4 minus 11 is like here. So we can see that it does have roots. Look at that beautiful graph, mate. Now respect it. How do we find then the roots? Simra, you being here is raising the grey boundaries. I can't lie. Majestic. Jack is positive 4. Good. Make it equal to 0. Guys, you don't need to use quadratic formula. You've already completed the square. Just make that equal 0. Exactly, Maz. Mazaline. You add the 11. You square root. So you get plus or minus 11. Plus or minus root 11. Yeah. And then we add the 4. Okay. Now, why is sketching the graph an advantage? Because without a calculator, you don't know, well, you can't decimalize that, right? Which root is that one? Which root is that one? Yes, DK. Zara, good. It's the negative one. Kira, good. Because obviously it's the smaller one, right? And the smaller one's going to be the negative ones. And the good thing about this is you don't need to decimalize anything to know which one's which. So there you go. 4 minus root 11. 4 plus root 11. And there you go. Part B, let's not forget that. What is Mosey? Nice, Mike. What is the equation of the line of symmetry? Sophie, 3 kg. 3 marshmallows, Sam. That's too much, man. Mariam, good. Yo, Mimi. Tom Wilde, the famous author. The line of symmetry is vertical, so x equals 4. Good. All vertical lines, good, Lima, are x equals. Horizontals are y equals. Okay. Next one. Proofs. I got you guys. Some of you guys were asking me about proofs and that. Prove that the sum of 3 consecutive even numbers is a multiple of 3. Can you guys give me the 3 forms for consecutive even numbers? Kaz, 2n is one of them. Mohammed, good. Well done. Now, Gemma, you're nearly there. We can't just say n plus 2. Because remember, n could be even or odd. All right? So remember, guys, in terms of defining even numbers, you have 0, 2, 4, 6, 8. All even numbers are 2 away from each other. Okay? So, the first even number is 2n. Now, if you guys want to, if you let this be 2n, you can add 2, be 2n plus 2, add 2 again, 2n plus 4. But this makes the algebra a little bit more difficult. Okay? My recommendation is instead of doing plus 2, do plus 2 and minus 2. Exactly. So do the plus 2, but then do the minus 2. So you get 2n minus 2. And there's a reason for that. If you look at 2n minus 2 and 2n plus 2, what do you notice about them? If I was to put them in a bracket next to each other, what do you notice about them? Nice, Chloe. Douglas, good. Difference of 2 squares. All right? That's why we prefer doing it this way. All right? So the consecutive evens, let's use 2n plus 2 and 2n minus 2. But I've just said prove that the sum of them is always a multiple of 3. So guys, when you add them up, what do you get? What do you guys get when you add them up? Yes, Fatima. Now respect it. Exactly, Robert. We love dots, mate. And here's another beautiful thing that happens. These cancel and we're left with 6n. Now you're not just done yet. What would you need to do next? Blaze? Yeah, you can use that. You get 6n plus 6 if you use that. Good, Libot. Pranav, good. So guys, I said multiple of 3, not 6. So you just need to rewrite it as 3 lots of 2n. Okay? Therefore, multiple of 3. It seems trivial, But just do it, mate. Don't question it. Just do it, mate. All right, now respect it. Next thing is prove that the sum of the squares of two consecutive odd numbers is always 2 more than a multiple of 8. Okay, guys, what consecutive odd numbers are we going to use? Which consecutive odd numbers are we going to use? Izzy, that's why I'm doing it with you. Gotta make sure you are more comfortable with proofs. Now, NZ, you can use 2n plus 1 and 2n plus 3, but in my opinion, there's better options. Sophia, 2n minus 1. Good. So, guys, remember, odd numbers are defined as numbers between even numbers. Okay, so the odd numbers are between even numbers. So, if this is your 2n, then the next odd number is 1 away, 2n plus 1. So the next odd number before that would be, you subtract 1, 2n minus 1. So consecutive means the numbers, or the odd numbers that are next to each other. Use 2n minus 1 and 2n plus 1. Okay, they're just nicer to use. Now you can use 2n plus 1 and 2n plus 3, but these are just nicer because remember dots. Prove that the sum of squares of two consecutive odd numbers. So we're doing 2n minus 1 squared plus 2n plus 1 squared. So we need to expand them. Guys, what does 2n minus 1 all squared expand to? Ranjit, because odd numbers are defined as 1 away from even numbers. Farah, yes, for the previous example. Thanks, Mohammed. Lupo, Dr. Lupo, yes. Aria, it's looking good, Mike. So you square this, 4n squared. You multiply these together, minus 2n, double it, minus 4n. Then you square the last number, 1. And then the other one would just be the exact same thing. It would just be plus 4n. What does that simplify to? Of course, Gawa, I remember the question, Hannah's sweets. Shout out Hannah in that. Salt and pepper. Bro didn't even finish pepper, but it's all good. They cancel. Wait, what? I just crossed off the wrong thing. Let's ignore that. This cancels. 4n squared plus 4n squared is 8n squared plus 2. And there you go, guys. The answer is there. It's a multiple of 8 plus 2. Okay? Multiple of 8. And then this is plus 2. There you go, mate. Proved. Proved. All right. Question like this, like 3 marks, I would say. And the one above, probably like 2. Yeah. Maybe 3 each. Maybe this one be 4, actually. More realistic. Okay. Could this be right? 8 bracket n squared plus 2n plus 1 squared. No, Yasmin. All right. Solving with algebraic denominators is a very common topic in non-calculator papers. For part A, what would you do first? What would you do first? Ayo, Chloe, we don't do that over here. We don't cross multiply. Especially when it comes to part B. Anyone who does cross multiplication bugs out when it comes to part B. Yes, Amara, good. We should be protecting first. And then what? I feel like you guys know me way too well. Parry, good. We multiply both sides by both denominators. The 3, guys, dividing by 3. We're going to multiply by 3. And we're going to multiply by the x plus 2. Okay? It just so happens that this is the same as cross multiplying. But when you guys are still in the phase of watching Peppa Pig, I don't like to say cross multiplication, but when you guys upgrade to A-level maths, then I'll allow you guys to say cross multiplication, okay? Then we should be expanding 3x. 3x minus 6 is 2x. 2x plus 4. S. Why? Because at GCSE, in general, students don't know the difference between these two questions, and they think you can cross multiply for absolutely everything because their teacher hasn't shown them the difference. Okay, so just be very careful. That's why I don't advocate for the word cross multiplication. It's bad practice. So here, yeah, Pranav, you're booging 24/7. Minus 2x, yeah, to bring the smaller x to the larger one, and then we're gonna add 6 as well. Yeah, we're gonna add 6. So what is that? X is 10. Okay, part B. What would you guys do first for part B? Nah, Ute, I'm right here, mate. Hattie, good stuff. Jakub, what's up, man? Jakub Konsek. So we have x minus 8 over x minus 1. The first thing we should be doing is protecting. Then what do we do? And this is why we don't say cross multiply. Good, Aisha. Brampri, that's just I wouldn't recommend that. That's just something we do with children, the kiss and smile method or the butterfly method. Is he good? So here, guys, we're gonna multiply everything by this x minus 1. Okay? So we can't cross multiply. We're gonna multiply everything by the denominator of x minus 1. We are scaling the equation so that there's no more x minus 1 in the bottom. So here we have x lots of x minus 1. We have the minus 8, which has no more denominator, is 3 lots of x minus 1. Okay. Then we obviously expand and solve. All right. Kemcho Ari. So we have x squared minus x minus 8 is 3x minus 3. Then what do we do? Yeah, it was one of my reals, Brampre. Not make equal to 1. We make equal to 0. Yes. So this plus 3x, we're going to bring it to the other side. We're going to minus 3x. We're always going to bring everything to the side of the x squared, the positive x squared. The minus 3, we're going to bring it over. We're going to add 3. So we get 0 is x squared minus 4x. What is that? Minus 5. Then what do we do? I am not Venus. Bro's making assumptions. Doesn't know anything about me. Factorize using the oi oi method. Ayo, it's not needed here. Yes, Jake. So we get what? X, 5, 1. Minus 5 plus 1. So what are my two solutions? Oi oi. Yo, Senor B. Alex, good stuff. So when we solve it, Jessica, yeah. So your x minus 5 is 0, and x plus 1 is 0. Yeah, two things multiplied to give you 0, so we're just going to add the 5. X is 5. Shane, you could complete the square on that. It would be a little bit extra, but for sure. And minus 1. Okay, good stuff. Good stuff. All right. Next one. Exact trig ratios. Now, when it comes to exact trig ratios, guys, you can basically figure all of them out in 1 second. Okay? All you guys need to know is one of the loins. You guys knew this was coming. If you remember this one, you will remember all of them. I know there's hand tricks and all that stuff, but guys, if you could just remember 5 numbers, you're all good. Sine of 0. What is that? What is sine of 0? You guys know about a table trick. I don't know what the table trick is, but sine of 0 is 0. Okay, the sine graph starts at the origin, and it does this. What's sine of 30? Nice, Aisha. A half, good. Yeah. What's sine of 45 degrees? Yo, Monty Python, always look on the bright side of life. Yes, Anaya. Bun Saudia Airlines. Ryanair is better. Root 2 over 2. Good. What is sine of 60? Bro said learn a song. Root 3 over 2. Root 3 over 2. And then finally, sine of 90. 1. Good. So guys, if you remember this, all you do is you copy it backwards. So look, I'm going to read backwards from here. 1, root 3 over 2, root 2 over 2, a half, 0. Okay? How do you find tan? What do you need to do to find tan? What's up, Floss? Yes, Diary, it's that simple. We divide. Good. Guys, what's 0 divided by 1? What is 0 divided by 1? 0. Good. What do you guys get when you have 1 over 2 divided by root 3 over 2? What's 1 over 2 divided by root 3 over 2? Now, Douglas, you can write like that. Yeah, it's up to you guys. But what ends up happening is the 2's cancel. They're both over 2, so they cancel. So you're left with 1 over root 3, which you can rationalize to be root 3 over 3. I'm just going to write 1 over root 3 because in the exam, if you don't remember it, you would just say, oh, I just need to delete the 2's. Okay? So 1 over root 3, which is the same as root 3 over 3. Okay? So I'll put that here. They're the same if you rationalize. What about root 2 over 2 divided by root 2 over 2? Sigil, good. Jacob, Barrett. Man like Jacob, 1. So guys, the 2's cancel here. What are we left with when we divide root 3 over 2 and a half? Douglas. Man like Douglas Costa and that. This goes. So, yes, the 2's cancel. We're left with root 3 over 1, which is just root 3. What about 1 divided by 0? Oh, 1 divided by 0. Let's see who remembers it's undefined. There's no such thing as tan of 90. Don't say infinity. Don't say 0. Undefined. So this is a typical difficult non-calculator paper question. Find the value of x in this triangle. What would we be using here to find x? You gotta just say what relates 3 lengths in an angle. Yes, Aiden, to infinity and beyond. Rashid, good. The cosine rule. So guys, the cosine rule relates all 3 lengths and an angle. Okay. Do you guys remember the cosine rule? I hope so. It starts off as Pythagoras' theorem. A squared is b squared plus c squared minus 2bc cosine of a. Now, the key thing is what lowercase a and uppercase a is. What would they be in this triangle? Yo, strawberry jam. And you'll learn it eventually. Bun the formula sheet. Good. 2x and 30. So, guys, your a's are opposites. Okay, so this is your a and this is your lowercase a. And these can be interchangeable as your b's and c's. Okay. So we have, when we substitute, guys, what do we need to make sure we utilize? Megan, it depends on the context of the question. Because sometimes having 1 over root 3 is just easier. You could just multiply through by root 3. Brackets. Brackets. 2x squared. Because if you don't use the brackets, you're going to make some mistakes. It's not looking good. So we got 2 squared. That one you don't really need a bracket, but we'll use it anyway. Good practice. Then we got root 3x squared. And then minus 2. What's up, Ella? 2. Make sure you get good results tomorrow, mate. Otherwise, it's not looking good. Cos of A. Now, in your exam, where are you going to get a mark? For saying what? Ayo, Drain, you're on a completely different question, mate. Yes, we get a mark for writing down cos of 30. Yeah? I mean, my recommendation is tomorrow, guys, just remember this line. Just remember this line and just write it down. As soon as you get into the exam hall, just write it down somewhere, yeah? So that um, you can remember it. And then you can forget about it. Okay, now, guys, what's 2x all squared? What is 2x all squared? Good, 4x squared. So you square the 2, 4, and then we square the x squared. This is obviously 4. What's root 3x all squared? I'm sorry, Miss Jasmine. Ooh, I am for you. Yep, 3. So, guys, when you square root 3, you get 3, and then don't forget you have the x squared. Minus. Now, I have 2 times 2, quattro, root 3, eggs, times cos of 30, which is root 3 over 2. Now, what does 4 root 3 times root 3 over 2 simplify to? Qui Rui, probably AQA. Thanks, just 2. Not 0. Nicole's saying 6. So 2 goes into 4. 2 goes into 4 twice. Then we have root 3 times root 3, which is 3. Okay, so it's 2 times 3, which is 6. Yes, x. Yeah? Greedy, good stuff. Minus 3x squared plus 4 is 4x squared. Then what would you guys do next? Next step. Zara, good. We make it equal 0. Should we do a Beyonce, move everything to the left, or should we keep on the right? Good. Beyonce in that. Yeah, it's not always Beyonce, all right? But yeah, in this case, we're definitely moving it to the left. We're going to move the smaller x squared to the larger one. So, we're going to minus 3x squared. Then the minus 6 is going to go over, so we're going to get x squared. Minus 6x on the other side is plus 6x. And the plus 4 on the other side is minus 4 equals 0. All right, how do we solve this? How do we solve that, mate? Good, Uma. Chloe, Sean, nice. So, guys, it doesn't factorize. So, you need to know in the exam how to solve something like this without being able to factorize. Complete the square. Can you all complete the square? I've done a lot of practicing for completing the square. It's probably the most important technique for non-calculator papers. Da Vinci, what do you mean by that? Which way round you put it? Do you mean moving it to the right? Yeah. Well, it doesn't. You'll still get the correct answer eventually, but we don't solve negative quadratics. Tanisha, x plus 3 squared minus 9 minus 4, which would be minus 13, which Chox looks to be getting as well. So we have x squared. We half the coefficient of x, which is 3. Subtract this number squared. 3 squared is 9 minus 4 is 0. Beautiful, mate. Beautiful. So we have x plus 3 squared minus 13 is 0. And now we can very easily solve that. Okay? So we add the 13. X plus 3 squared is 13. Square root both sides. Bruh, running out of space, man. This question is juicy. Shout out Biggie. I'm going to move that over. Alright, you guys happy with that? Piano do. Well, I've just shown you an example where we are completing the square without finding the turning point. No! Hey, yo, guys, come on, mate. You guys need to wake up. Too much sleeping. Too much watching Coco Melon. X can't be negative. How can X be minus 3 minus root 13? Come on, guys. Come on. This is why you guys are here, raising the grey boundaries out here. So if X is bigger than 0, X is minus 3 plus root 13. This question here, guys, can be 6 marks in the exam. 6! Eminence, I know it's true, man. Calante is not partial differential equations. Yo. Iru, yeah. Should be 0.2 marks. Ayo, that's crazy. The people bringing down the grey boundaries are the ones who are not in this stream. So just a reminder, guys, remember there's cram courses for every single subject. You can sign up in the description. Big up yourselves. Okay. Quadratic simultaneous equation. How do we solve this? What would you do? Ayo, that's crazy. Derivative is asking when I'll do derivatives. I got loads of stuff on YouTube. Althea, good. So we use substitution. So we need to make the subject in equation 1 or equation 2. Do we make x or y the subject in equation 1 or 2? Nice, Jasmine. Ooh, I am for real. Never meant to make your daughter cry. So yeah, we make x the subject in equation 2. So we take the positive 2y, we move it over. I actually did a spreadsheet on all my TikToks, and it turns out that I've done the most questions on quadratic simultaneous equations. So if you guys go through my GCSE TikTok, you'll find the most on this stuff. So the plus 2y goes on the other side is minus 2y. Then what do we do with this subject equation, which we can call equation 3? Kidus, because we didn't have access to a calculator. That's why we complete the square. Good, Sean. We're going to take this and plug it into the first equation. So we square it. Don't forget to use brackets. And then we need to expand the brackets. Okay. So we square the 2, quattro. We multiply these together, minus 4y. Double it is minus 8y. Then you square this is 4y squared. Obviously, guys, you can write out the brackets twice. Okay. It's 20 in the book. Okay, where does it say 20? If it says 20, I don't know, hockey is bugging. I don't know where you guys are getting 20 instead of 2. Here it's saying 20. Ah. Well, let's go with this. I think when Hockey was pressing Z or something. I don't know. They're bugging. Change it to 2. Change it to 2, mate. Change it to 2. Alright, what do we do next? Next step. Yep, we subtract the 17. And here we'll know eventually if... it's definitely not 20. We're definitely not squaring 20 and working with 400. Hockey is booging. Okay, so that's done. So we get 0 is 5y squared. Use chaos theory. Hey, yo, that's wild. Alright, now what do we do? The best part of the day. Factorize. Using. Yes, Alvia. Oi, oi, mate. Gonna use the oi, oi method. Yes, Amar. Come on. Now, the beautiful thing about this one is we have a prime. What has to go here and here? Yes, TR. Hey, yo, Nathan. Haters gonna hate, potatoes gonna potato. So what multiplies to give you 5y squared is 5y and y. Good. Now with 13, what are our options? What are our options? Yeah, 13 and 1. Now, guys, think about this. Are you going to do 113 or 13-1? Which one is going to be the obvious choice here? Which is the obvious choice? Hattie, Uma, good. Safa, Chocks, good. Guys, you do not want to put 13 here because then you'll be doing 5 times 13. That's 65. You're trying to make 8. So, guys, for sure 13 and 1. You can see how logic just allows you to factorize super quick. So 13 and 1. And now we do oi oi. 5y times 1 is 5y. This is 13y. That does make minus 8 if you have minus 13 plus 5. There you go, factorized. What's 9 plus 10? That's a good question, man. It's a good question. So what are two solutions? What are two solutions? What's 9 plus 10? Yo. So minus 1 is one of them, and the other one is... So you have either 5y minus 13 is 0, or y plus 1 is 0. So yeah, one of the easy ones is y is minus 1. Then the other one, good. We're going to add the 13. 5y is 13. dd, divide by 5. Alright, so we're finished, yeah? GG, dd. Jessica said no. We getting 240 out of 240 with this one. Okay, we need to find x. Let's do it with the easy one first. X is 2 minus 2 times minus 1. What's that? I am for real. Never meant to make it not a crack. Good, Alex. So we have 2 plus 2 is quattro. So there you go. So your first solution is x is 4, y is minus 1. Okay. This one is a little bit more tedious to find. First things first, what's 2 times 13 over 5? What is 2 times 13 over 5? Good. When we multiply, guys, it goes to the numerator. Okay. So, what's up, Ifa? So we have x is 2, which we know we're going to write over 1, minus 26 over 5. Can you guys just subtract them? What's your final answer? And then I'll confirm if you're correct. Account. Good stuff. DJ got, and Lydia got minus 16 over 5. Ari as well. Harvey. Harvey Miles. Must be related to Miles. So, Neil, please stop teaching them. The grey boundaries need to go down. It's fine. The small population who are on here, they'll raise the grey boundaries for themselves. So it times in top and bottom by 5, we'd get 10, which is minus 16 over 5. Now respect it. So there's our solution. Minus 16 over 5. It's not looking good for the students who are not in this chat because they're missing out, man. Their grey boundaries. They're bringing the grey boundaries down for you guys. Sujal, what's it called when you times the first one by the last one? For example, 5y squared with minus 13. I'm not sure what that means. I'm not sure what that means. Sujal, don't spam it though, because you need to clarify what you actually mean. Otherwise, if you spam it, I just won't answer your question. Quadratic inequalities. Quadratic inequalities. Determine the range of values of x that satisfy both of these inequalities. What would you guys need to do? Hatim, yes. If a question actually asks you to find the turning point of a quadratic, if you differentiate, you will get the marks. Yeah, so for the first one, guys, we just need to expand it, find the x value. What is that? 4x plus 4. What did you guys get when you solve for x? Mohammed, unfortunately, you have to be a main course student. Jasmine, as in you learn differentiation in further maths only, but it's clearly stated in exam guidance that if a student uses a valid method, they will still get full marks. Abdul, good, -4. So we take the 4x over, we minus it, and the 8 minus 8. But I still recommend that you just stick to the normal GCSE methods, but you will get the marks for differentiation. Okay, so we have this one. Good. Now question 2. And also the previous question, guys, because we had to factorize that awkward quadratic, it could be worth 6 marks, 5 or 6 marks. All right. X plus 1 squared. Can you guys help me out? Can you expand that? I'll do the other one. X squared. We have 2x plus x, which is 3x. We have 2. All right, good stuff, homies. So we get x squared. X times 1 is x. We double it, 2x. And then we get plus 1. Then we have minus 8x squared. Then we get minus, what is that, 24x. Minus 16 is less than 0. Simplifying. What do we get? Minus 7x squared. 2x minus 24x is minus 22x. 1 minus 16 is minus 15 less than 0. All right, what would you guys do next? Do you know what's crazy is that there is over 2,000 students, well, about 2,000 students, and you're all taking your education very seriously. That's crazy. I respect it, guys. I respect it. Yeah, we can times through by -1. Now, when we times through by -1, what do we need to be careful of? Iru, what do I mean? I mean, if you go to other chats, you can see that students aren't serious. But here, everyone's serious. So we switch the arrow. Good. So guys, when we times through by -1, you have to make sure that the sign flips. Why so serious? Okay, so we get this. We're locking in. All right, what are we going to have to do here, guys? What do we need to do? I wish, Jake. Lena, why -1? Because we want to solve positive quadratics, not negative quadratics. Good. Now we need to factorize. Okay, oi oi. So let's do it, mate. So we got 7x squared, 22x, 15, bigger than 0. Alrighty. What goes here and here? If it's -16, it's not -1 though, it's -16 plus 1. Good, 7x and x to multiply to give 7x squared. Now with 15, we obviously have options, 1 and 15, 3 and 5. Which option should we try first? In general, which option should we try first? Amar, good. Safa, good. So in general, guys, you always try the option closest together. Okay, because in general, that's the one that always works. Okay. Now, if we try 3 and 5, does it work? Yes or no? Does it work? Yes or no? If you guys were to expand the middle terms, would it end up working? Let's see. Good. The answer is no, because 7x times 5 is 35x, and this is 3x. That can never make 22. How about if I switch them around? Does it work if I switch them around? And eventually, guys, you can do it without even writing it down. You would know if something works or not. Kira, good. Said, that's it. The answer is no, because that's 21x, and this is 5x. That can never make 22. Well done. So what I'm showing you guys is what you could be picturing in your head and know that 3 and 5 does not work. It's going to have to be 1 and 15. Now, guys, are you going to do 1, 15 or 15, 1? Which one is it going to be? UK World says 15-1. Yes! We raised in the great boundaries with this one. 15-1. Guys, the 15 can't be on this other side because you'll be doing 7x times 15, which is huge. All right? Okay, so what do you already know that the signs have to be inside? 7x times 1 is 7x. And this is 15x. I don't know. Good. Good. It has to be plus. To make 22, they both need to be plus. Ayo, this question's crazy. This is a question that you guys are going to need to watch again tomorrow morning. We have a quadratic inequality. What else are we going to need to do here? What else are we going to need to do here to solve this? So Rashid, find the roots. And then what? So we need a number line. And, guys, we're going to have to sketch it. Okay? So, guys, if you were to make these equal 0, what would your roots be? So, yeah, we definitely should draw the quadratic. So, tune, one of them is -1 for sure, if you make that equal 0. And the other one, not 15 over 7. Abdullah, be careful because it's 7x plus 15. When you move to the other side, it'll be -15. Okay? So, guys, you cheeky draw the picture. Yeah, you draw the quadratic, -1 and -15 over 7. Now, look at the inequality. It says bigger than 0. Do we want above the x-axis or below the x-axis? Do you want above or below? Good, above. This is saying we want the quadratic to be bigger than 0. Bigger than 0. So above the x-axis. Okay? So which x values, guys, define those sections? Which x values define these highlighted sections? Because S, this means you want the positive y values. Douglas, good. Abbas, other way. So here, can you see we want bigger than -1? So I want these x values. So I need x to be bigger than -1. And then on the other side, Nguyen, good. We want less than -15 over 7. So guys, we need x to be bigger than or equal to -4. And we need it to satisfy these as well. What do we do next? You're welcome, Zedtune. Good, Safa. The next thing, guys, we need to do is we need to use a number line. Okay? So, we have x is bigger than or equal to -4. How do we draw the circle for bigger than or equal to? How do we draw the circle for bigger than or equal to? I don't know. Good. We shade it. Izzy. Good. So we need x to be bigger than or equal to -4. Okay. Now we also need x to be less than -15 over 7. Guys, is -15 over 7 going to be on the left or the right of -4? Which way, on which side is it going to be? Right, good. Because this is basically about 2. 7 goes into 15 about twice, isn't it? So -15 over 7. Okay. So I need x to be less than that. All right. And then the other one is x has to be bigger than -1, which is over here. What are we looking for? So you guys told me to use the number line. What are we looking for here? Uma, not the intersection. I know what you mean though. Afia, good. The overlap. Thanks, Sophie. So guys, we're looking for the overlap. Now here we go. Here's one of the overlaps. How would you guys describe this overlap? So you're looking at when the top lines and the bottom line overlap. Mia, good. Gemma. Okay, now you're close. Guys, if I write this, That would be incorrect. Does anyone know why? Why would that be incorrect? Why would that be incorrect? Mohammed, good. So guys, it's more so that -4 is allowed to equal, so it can equal -4. Okay? It can't equal the -15/7, so we have to be very careful with this question. Now the other overlap we can see, guys, is just on this side. So that is just standard. X is bigger than -1. Yeah? X is bigger than -1. Now, guys, this here, alongside vectors, which we're going to do later on, very soon, obviously, is probably one of the toughest questions they've asked in GCSEs. Okay? Something like this could be 7 marks in the exam. Obviously, I'm trying to impart my knowledge to you guys. Yeah? Uma, are you allowed to bring a highlight in GCSE? I mean, technically, yes, but the scanner doesn't pick up the highlight. 7 marks! Mr. Bean, scam. It should be more like 20 marks. Sully, it's not that hard. That's good. If you don't find that hard, that's a good sign. That's a good sign. So, Nguyen, yes, there's 2 answers. The next thing we need to cover is congruence. For triangles to be congruent, they have to be the same shape and size. So you're only allowed to rotate the shape and reciprocate it. Now, there's 4 different ways in which we can prove triangles are congruent. Who knows what this situation is? Nice, Abdullah. SAS, good. Side, angle, side. So if you have 2 triangles where the side angle side or a side angle in the middle, so guys, it has to be in the middle, is the same, then it's equal. All right. So the way I remember this, guys, anyone who's been watching me will know I say Suarez and Sturridge, Sturridge and Suarez. If you're a Liverpool fan, you might remember. I know you guys are like 6 years older than that. You might not remember who Suarez and Sturridge are, but that's how I remember SAS. Okay, Suarez and Sturridge. But your parents will probably know who Suarez and Sturridge are. So, guys, can it be in any order? Could you have SSA, for example? Is that allowed? So 2 S's and an A. Good. No. So, guys, you need to make a note that is this order only. This order only. Okay. Now, what about this next one? What is that representing? So remember, guys, SAS. Yes, Tanvir, the guy who bites everyone. AAS, good. So this, I have a side, angle, angle. Now, it depends how you read it. SAA, AAS. Okay, SAR. It's not Leviosa, it's Leviosa. But can it be in any order? Is ASA allowed? Is that allowed? Nick, I look like Shaqiri. That's crazy. Good. The answer is yes. Because what do you automatically know from this situation? You know the third side. So guys, if you have 2 angles, you always know the third angle. Okay? So that's why any orientation of this is okay. Okay? So any order. It just depends on the question. Okay? So SAS, that order only. 2 angles and an S can be in any order. Okay? So, what's this third one? That's an obvious one. That's an obvious one. Not AAA. Be careful. Amber, nice. So, this is 3 sides. And obviously, in any order. Yeah? Big up yourself. So, S in any order. What's this last one? We're making the dollars. Let's go. Ka-ching. Yes, Azzy, we will be. RHS, good. Right angle, hypotenuse, and a side. Okay, RHS. If you can spot that, they are congruent. And that can be in any order because they're unique. Okay. Now, the way I remember this is right-hand side. Right-hand side. Okay. All right. Let's apply it. ABCD is a skirt. BFD and ABE. Arbe is back. Shout out Hoya. Are equilateral triangles. Proof triangles ABF and EBD are congruent. Alright guys, let's do it. ABF with a ruler. I don't need a ruler. My lines are too goated. Prove that that triangle is congruent to EBD. Man like Abdi. Alright. What would you guys say first? So you're basically looking at these two triangles and saying, what's the same? What is the same? So you can't tell me SAS. You have to tell me what things are the same. Sakana, AB equals BD. Good. So first thing, guys, we can see that on the black triangle, AB is equal to BD. Okay, because it's a square, isn't it? So all of these are the same. So AB equals BD. Yeah, because we have a square. Skirt. So there's a side. What else? What else? AQA. AB equals BD. AB equals BD equals BF equals nice. AQA. So guys, I gave you a key piece of information in the question. I said that the triangles are equilateral. So if they're equilateral, if they have this length here, then all the other ones are the same. All of these are the same. So what you could say is that what you guys are saying is correct. Is that this length, EB, is the same as this one here. Okay? So EB equals BF. Okay? That's another side. Okay? Square attached to equilateral triangle. Okay, what's the last thing we could say then? Pythagoras' theorem is not happening here. Cheyenne, EBD is ABF. EBD is ABF. Nice. So the last thing we could say here, guys, I'm just going to get rid of this highlight here, is this angle here is the same as this one. You can actually tell me what they are. What are they? Nice, Newen. Aria, good. You can actually tell me what they are exactly. Not 90. S, good. Gemma, good. BB, good. It's 60 plus 90. So guys, let me show you. Remember we're dealing with an equilateral triangle, right? So we have this angle here is 60 degrees, and we have the 90 degrees. That just gives you the blue one, okay? So we can say EBD is ABF is 150 degrees. That's an angle. Wait, I thought we can't prove congruence SSA. I thought we can't use two S's. What's going on here? Jasvine is saying it's actually S. Okay, good. So guys, we have actually proved SAS. I want to be very clear with you that the order in which you said things are the same is not necessarily the order in which you proved it. You proved side, angle, side. You actually proved it using SAS. Okay? So, they are congruent, sassy. Okay. There you go. So be very careful. Okay, be very careful. We can't use triple S because there's no way of proving that AF is the same as ED. Okay, sassy. All right, Aisha, because they want to raise the gray boundaries. Let's go. What number needs to be added to 4 and 9 so that the ratio of the first number to the second becomes 4 to 7? This is a cool question. How do we deal with this one? See if Farah. He has the 1. Nice S. So no trial and error. Guys, if you ever find yourself doing trial and error, it's not looking good. Okay? So you have to set up an equation. Is you're close. I said what number needs to be added? What number? X. Let's call it X. What X value do I need to add to 4 and 9 such that the ratio between them is now 4 to 7? That's beautiful right there, Mike. All right. Would you get the marks if you use trial and error? Most likely in the exam, they would say use an algebraic method. Okay. So, yeah, you wouldn't. Trial and error wouldn't give you the right answer. And they're pretty firm with that in the mark schemes. So good, Susie. Now, if you have watched my YouTube video on this very recently, what does a ratio symbol actually mean? What mathematical operation is a I just gave it away. It's divide, yes. So guys, shout out to the Eastern Europeans. They use the ratio symbol to actually represent division. You're basically saying x plus 4 divided by x plus 9 is 4 divided by 7. And we need to solve that. Okay? So, what do we need to do to solve this? All good, Susie. We're going overtime because we're trying to get the top grades and raise the grade boundaries for ourselves, whilst everyone else is falling behind. Okay, I know you guys love this whole cross multiplication, but I've taught you better now. That we protect Hattie exactly, and then Uma, we times both sides by both denominators, the 7 and the x plus 9. Alrighty, mate. So we cancel. The x plus 9s go. We expand 7x plus, what is that? 28. Is the 7s here cancel? 4x plus, what is that? 36. Alright, guys, solve for x. What does it give you? Nice, Aria. Siege cross rebellion. Michaela, good. So, guys, we take the 4x. We're going to minus it. And then the positive 28, we're going to minus 28 to the side. So 3x is 8. And then we divide by 3. And there you go. Now, guys, some of you were asking about trial and error. Trial and error is never going to give you this answer. Because when you do trial and error, you're always thinking about whole numbers, right? So if they were to ask this in an exam, the answer will be something that you would never guess. All right? All right, ¿qué pasa? Some tree diagrams and ratios, something like this can still come up in a non-calculator paper. It's a big test of your algebraic skills. I got you, Layla. Got you. Giving you guys nines. For real, Lungang. Noise. There are some. I haven't had any water, man. I got my ghost water over here. Look at that. That's pretty cool, right? We have some water. Stay hydrated, man. Abdullah, if it was a perfect world, I'd sit the paper for all of you guys. I got you guys, man. Overtime, always. Don't be that guy that's complaining about overtime. That's not looking good. Well, actually, we thank the people that are complaining about overtime because they lower the grade boundaries for themselves. Aryan tuna smoothie, always. All right. We'll be done soon, though. There are some red and blue counters in a bag. The ratio of red to blue is 2 to 3. 2 counters are removed at random. The probability that both of them are blue is 7/20. How many counters were in the bag before they were removed? Just put the fries in a bag, bro. Now, what can you guys tell me about this ratio? Jonathan, I want to raise the grade boundaries for you guys in the stream, but then everyone who's not in the stream, they will be lowering the grade boundaries. Good, Aisha. So, this ratio, guys, could have been simplified, okay? This ratio has been simplified, so we need to unsimplify the ratio, all right? By what students are saying in the chat, we need to multiply them both by x. We don't know what the simplification was. We're saying, was it 4 to 6? Is it 20 to 30? We don't know. So we say 2x to 3x to represent the scale, okay? So that is red, and this is blue. So if we were to do a tree diagram, guys, do not fill every single branch. Which branch are we interested in? Which branches? Which branch or branches are we interested in? Good, Amma. Safa, good. Rashid. Hattie. Blue. Nel blu. Ti pinto di blu. Felice di stare lassù. So here we said both counters being blue is 7/20. All right. Now, given there are 3x blues, what is the probability of choosing a blue counter? Olivia, how do you know it wasn't simplified? Floof, good. Path, good. So guys, there's 3x blue counters out of 5x in total. Okay. Now, don't simplify it just yet. We'll simplify it later. What would be the probability of choosing another blue? If there's 3x blues, you've taken one out. Good, Safa. Uma, good. So guys, the most common answer is saying 2x. It is not 2x. You are not subtracting x counters. You're subtracting 1. So guys, if you said 2x, make a note somewhere to remind yourself that you're subtracting 1, not x. And the same thing goes with the denominator. Okay? Now, what do we do to these probabilities when we go across the branches? We'll see, Seb. Good. That's it, guys. We times them. Marique's good. So we're doing 3x over 5x times 3x minus 1 over 5x minus 1 is 7/20. Okay? And now we need to solve this. How do we do that? Yes, Anaya, I respect it. Good, Asaid. Sophie, because it simplifies to 5x, right? So, Jonathan, no, 1 are removed for the second one. The first one, nothing's even been taken yet. So these simplify, these cancel. Okay, and then we should be protecting. Good. All right. Now, if you guys want, you can expand the bracket. I gave a slightly different method to the students in the main course. I just divided by 5 on both sides, but let's just expand. Thanks, Mohammed. I'm a great singer. I'll be on Britain's Got Talent soon. 3 times 3 is 9x. 3 times minus 1 is minus 3. Then we have 5 times 5x, which is 25x. And then 5 times minus 1 is minus 5. All right, then what do we do? 9. Yes, S, we can. If I go on Britain's Got Talent, you guys better vote for me. I swear, mate. Jonathan, yeah, we should be protecting again. And then multiplying both sides by what? Protect. We raising the grey boundaries with this one. DJ Khaled. Let's go. 25. All that cancels. 20 times 9 is 180x. 20 times minus 3 minus 60. Here the 20s cancel. 7 times 25. What's that? 175? I think. Is that right? Come on. Quick maths, Amber. Quick maths. Synthetic. Minus 35. Alright, solve for x for me, guys. What does that give you? Solve for x. Else who? Roblox on top. That's crazy. I'm seeing 25. Let's see. So the plus 175, we're going to minus 175x. And then we're going to add 60. So you get, what is that? 5 eggs. Is 60 minus 35, which is 25. Good. Eggs is 5. Alright, you finished? Ali Shush. Good stuff. Nah, G. Oh, I like your cut, G. So, we wanted the total. We wanted the total in the bag. It was 5x. So actually, the answer is 25. You don't even need to go and work out x. The total is 5x. Now respect it. Let's go. Okay. So yes, Seb, you were correct. Well done, mate. Well done. Yes. Question like this, 5 marks. We raising the grey boundaries with this one. Now, we finish off with vectors, guys. I think there's only like... Yeah, there's not much. Just 2 questions on vectors, I think. No, 3 questions. Okay, we're nearly there. We're nearly there. OABC is a parallelogram. N is on a point on AB such that the ratio is 4:1. P is on BC such that the ratio is 2:3. O to A is A, O to B is B. Write down an expression for A to B. Alright guys, that's easy. What's that? Ayo, Talia. Don't worry. It's very important after this, guys, you go to sleep. Maybe have a good din-dins and then go to sleep, innit? I'm starving like Marvin. Yes, Joseph, I am. Good, guys. If all else fails, just assume the answer is minus A plus B. You follow the directions. Now here we're going against A. So minus A, and then we're following B. So A to B is minus A plus B. But we like to write the positive term first, so B minus A. If you notice, guys, I underline my letters to indicate it's a vector. If you do not underline, it is okay. Alright, so don't stress about it. Show that N to P is parallel to OC. Show that N to P is parallel to OC. What would we need to prove here? What would we need to prove here? Yes, Sophia. Shocker. Hattie, good. Pranav, good. So Douglas, that's for collinear stuff. But if it's just parallel, we need to prove they are multiples of each other. Good, Toby. Guys, what is O to C? That is the easiest one. What is O C? What's that one? A plus B, good. A, and then parallel means this is B. So A plus B. Well done. A plus B, mate. And then we need to find N to P. Now with these harder vectors, guys, lay out your pathway. How are you guys going to go from N to P? What's going to be your route? Tell me your route. Route. York, Pilot, NBBP, good. So I'm going to go N to B, B to P, good. NB and BP, good stuff. Now, what can you guys tell me about the vector NB. What can you guys tell me about this vector, N to B? Dawn, good. Ras, cool. Good. Good, guys. It's one part out of 5 of the line it sits on, which is A to B. Good. Plus B to P. What can you guys tell me about B to P? What can you guys tell me about B to P? Dory Elaine is scrolling back. 2/5 of A. Nice. It's 2 parts out of a total 5 of this vector, which we know is A. Nice. So we have 1/5 of A to B, guys, which we know is B minus A. Always lay out your pathway in vectors. It's going to make your life a lot simpler. Expansion. 1/5 B minus 1/5 A plus 2/5 A. 1/5 minus a fifth plus 2/5 is a fifth, isn't it? Elaine, I'll discuss collinear in a second. Then we have the plus 1/5 B. What would you guys do here? Now respect it. Factorize a fifth, good. And what do you guys notice? About both OC and NP. Good, they are both scalar multiples, Aria, of A plus B. So they're both multiples, of A plus B. Therefore parallel. That's all you need to say. Easy dubs. We raising the grey boundaries out of this one. Chris, am I not tired? Never tired. With the A-level lot, I do 12 hours streams. I could go on for days. I can go on for days, mate. Light work path. What do you mean, lies? Last year I did a 12-hour stream with the A-level lot. I can go on for days, mate. So the next one is collinearity. This is where we start borderlining the hardest questions that they can ask in GCSE. So points are said to be collinear if you can draw a straight line through them. So here, guys, you can see OMN is collinear because you can draw a straight line through all 3 points. However, this, you cannot draw a straight line through all 3 points. They are not collinear. Now, if a question asks us to prove that points are collinear, what would you need to suggest about particular vectors? So, for example, what would you have to say about OM and ON? What would you need to say about them? And on, good, are parallel. Yeah, so the first thing you need to show is that OM and ON are parallel. Because you can see here, guys, look, OM and ON are not parallel to each other. Whereas in this situation, they are. So that's the first thing. And, good, guys, we need to suggest or state that they have a common point. Because, you know, train tracks, they are parallel, but they're not on the same straight line. So the next thing we would need to say is that they have a common point. Okay? Yes, Debala, exactly. That's why we need to say they have a common point. So you need to say 2 things. Okay, so you need to first say they are parallel, which is multiples, Althea. So that would be shown by suggesting they are multiples of each other, and they have a common point. All right? Yes, Amma, we should remember these words. Thanks, Esme. Okay, let's try a question. OAB is a triangle. N is the point on AB, such that the ratio is 1 to 2. Prove that PNC is a straight line. Okay, so remember, guys, you need to tell me 2 vectors that we need to prove are parallel. Which 2 vectors are you choosing? Which 2 vectors? Okay, now my suggestion, guys, is, Pranav, good. Do not do PNNC. You are just creating so much work for yourself. PN is one of them, but you must always do the endpoints. Pn and PC. Because from the diagram, you can immediately tell me what PC is. Guys, don't waste time in an exam. This is why you're here. We're here to raise the gray boundaries, not lower them. What is PC? Hastor said 2A plus A. Good. Don't forget we're starting at P though. So that's OC. Laptop, Nihao. That's a good one, mate. That's a good one. Gemma, 3A minus 3B. Pranav, Vaz, good. So we're minusing 3B. And then here we're adding 3A. Okay. So PC is 3A minus 3B. I like to write the positive one first. Now, because I already know that we're going to be proving parallel, let's just factorize out the 3. Dodgy B in that. Now, the next thing is Pn. Can you guys give me a pathway to go from P to N? How are we going from P to N? Yes, Amar, like I already told you. Connor, good. I would go the quick route, guys. Go from P to B, B to N. So PB and then BN. All right. Now we know what PB is. Personal best, 2B. What would you guys tell me about BN? Josh, good stuff. Manamanam. Do 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 do. Manamanam. Do 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 do. Manamanam. 2/3, 2 parts out of 3 of BN. Sorry, BA, British Airways, my bad. It's 2/3 of the full line. BA. Now, guys, can you tell me the vector BA? What is the vector BA? British Airways, AJ, for real. K said minus 5B plus 2B. Let's see. So we're going this way, which is going to be minus 5B. You're going against the arrows. And then we're going 2A. Good stuff. So we have 2B plus 2/3 BA, which is 2A minus 5B. All right, we're raising the gray boundaries with this one. What's 2/3 times 2? What's 2/3 times 2? 4/3, good. So 2/3 times 2, guys, remember you always multiply the numerator. So 4/3 A minus 2/3 times 5, which would be what? Minus 10/3? Nice. All right, guys, what is 2 minus 10/3? What is 2 minus 10/3? Nice. Now respect it. So times top and bottom by 3, we get 6/3, which is minus 4/3. So we get 4/3 A, and then minus 4/3 B. And look at that, guys. You can factorize out the 4/3. What is this? This is Pn. A minus B, innit? There you go. Both multiples of A minus B. So both PC and Pn are multiples of A minus B, therefore parallel. And what's the last thing we need to say? What is the last thing we need to say? Good, the common point. Okay. So the last thing we need to say is that they both share a common point. P. Okay. And that's it. Therefore, PNC is a straight line. Good stuff, guys. We're raising the gray boundaries with this one. Neil writes sentences. Neil does handwriting. Okay. Let's go. Let's go. Let's go. Can you say a common point N? Not here because we did PC and PN. If you did PN and NC, you would say N. But remember, I told you NC is a really awkward vector to find. Okay. All good, Susie sheep. Last one. I do read books. Okay. OABC is a parallelogram. M is the midpoint of BC. N is the point such that ONNM is n to 1. A and B is a straight line. Work out the value of N. This question here, guys, cooked most GCSE students. But it's all good. I got you guys in it. So we always start with the given statement. Okay? We always start with the given statement. If I say A and B is a straight line, what needs to be true? And I've said the ratio here is n to 1. You're going to need some crumpets for this one. Yes, Mohammed, we did. Pranav, good. So what are parallel? So you have to give me two vectors which are parallel to each other. So which two vectors on that black line that I've just drawn are parallel? Good. So we do AN and AB. So in this question, guys, why would you use NB? Which is why I'm always saying use the endpoints. We're saying AB and AN are parallel to each other. Okay. So AB and AN are parallel, meaning they are multiples of each other. Okay. Now you guys can easily tell me what A to B is. What is AB? What is A to B? Okay, exactly. When in doubt, B minus A. Yeah, say I can chill for a little bit. So we're gonna do minus A, and then we're gonna add B. Good. When in doubt, B minus A, innit? Now we need to find an. Can you guys tell me the route I'm gonna take to go from A to N? What route are we gonna take? How are we doing that? So we're starting at A. Yeah, we're gonna go to O. Good. So guys, we're gonna go AO, AO, and then we're gonna go ON. Okay. So you're gonna go AO and O to N. Okay. And we know AO. Let's go. And we already know AO is minus A. Now here's where things start to get a bit mad. What can you guys tell me about this vector O to N? What can you guys tell me about this vector O to N? Nice Dexter play. Dibala, good stuff. Hattie, N out of what? Safa, good. So a deal, it's an unknown fraction, but we can represent it. Guys, remember this one? We said 2 divided by 2 plus 1. Yeah, it's 2 out of 3. We do the exact same thing. Good, Yusra. It is n parts out of n plus 1 of the line it sits on. O, M. Okay. So let's take that up here. So we have A to N is minus A plus N over M plus 1. Now, guys, what is O to M? Let's see if you guys can see it. What is O to M? Just look at the diagram. What is O to M? Just follow some quick pathways there. Nice, Mohammed. Taj, good. K, good. Abdullah, nice. So, guys, look at this. To go from O to M, we're going to go B plus half M. Yeah? Half A, there you go. So we have a half A. I'll just do it in alphabetical order. Half A plus b. Okay. And now we're going to expand. Now, guys, when you do n over n plus 1 times a half, what does that give you? Y R, because we're starting at O. It's OM, right? So we have to do B first. Dibala, good. Taj, good. I didn't Nihao, because that's a foundation topic. Hallam, good. So guys, when you multiply, yeah, you're doing n times 1, which is n. And then here you're multiplying. Now, my recommendation is 2n plus 2 is correct. Well done, guys. But just keep it factorized because things might cancel later and you'll see potentially things might cancel. Okay. So just keep it like this. And then, guys, finally, we have got, finally is happening to me. We've got n over n plus 1 times b. Okay. Now, the next thing we need to do is we need to collect the like terms. How do we collect the like terms like these? What would we need to do to collect these like terms? Jess, bearings most likely will come up in calculator paper because you're working with angles, right? You factorize out the a, good. So guys, the only way to collect the like terms here is to rewrite a in one place, which is to collect the like terms by factorizing. So we open a bracket, a. We write the positive term first, n over 2n plus 1. And then here, that's a minus 1. We just write that down. Obviously, that looks horrible, right? What would you recommend we do next? Please, because it represents a vector. Good, Yaz. We should write as 1 over 1 because what are we going to end up doing? Mags, essentially, yes. We should bring the fractions together. Okay? We'll bring the fractions together. What would the common denominator be? What is the common denominator? Okay, good. Aryan, not just n plus 1. We need one of everything, so it's the n plus 1 and the 2. Okay, the n stays as it is. But for this one, we have to times top and bottom by 2 lots of n plus 1, isn't it? Okay, so we're going to subtract 2 lots of n plus 1. What does the numerator simplify to? What does the numerator simplify to? Sorry, man, I missed the last one. Is it just n? Don't know about n. So we have n minus 2n. Then when we expand, we get minus 2. So it's minus n minus 2. Okay. All right. We're nearly done. So this is an. Now, guys, we said that these two vectors are parallel. Okay. Guys, if a vector is parallel to this, can you give me an example of a vector that would be parallel to b minus a? Give me a vector that is parallel. Good, Mohammed. Amar, good. Pranav, good. Arya, good. So the most obvious one, like you guys are putting down, good, Dave, is 2b minus 2a, just times it by 2. Now, guys, do you notice that the coefficient of b is just the negative of the coefficient of a? Okay, so the coefficient of b is just the negative of the coefficient of a. Yeah, so it's not ratio 1 to 1, it's negative. So if you times the coefficient of a by minus 1, you get the coefficient of b. Okay, so if you take this coefficient of a, if you times it by minus 1, you get the coefficient of b. Guys, when you times this by -1, what do you get? If you take that fraction, multiply it by -1, what do you get? Skill issue, yeah, it becomes positive. N plus 2, good. You times the numerator, so it'll be n plus 2 divided by 2 lots of n plus 1 is equal to now the coefficient of b, which is n over n plus 1. What do you guys notice happens? What do you notice happens? Dawn, the m. Okay, yep. Good K. Ayo. We raise in the gray boundaries with this one. Do you see, guys, how they both have n plus 1? If you times both sides by n plus 1, they just cancel. And you're just solving n plus 2 over 2 equals n. How would you solve that nice and easy? Now respect it. Yeah, you saw we already did that. So we times both sides by 2 to get rid of that denominator. So we have n plus 2 is 2n. Guys, what's your solution? Let me say exactly. Move that over. N is 2. And there we go. Now respect it. Obviously, guys, if you guess n is 2, you are not getting the correct answer. They will give you 0 marks. But at least write b minus a. Guys, this is one of the hardest questions they have ever asked, okay? I recommend you watch back some of these for tomorrow. Guys, remember there's more cram courses. We are still doing it for paper 2 and paper 3. Guys, don't forget the free revision resources. Scan this, guys. You'll get more resources, not just maths, okay? It's going to help you out for English and the sciences. And just another thing, guys, if you get an email to review this session on Trustpilot, I'd really appreciate the 5 stars. It helps me out a lot. So thank you, guys. I'm hoping it did help you out. Good luck tomorrow. We're raising the gray boundaries with this one. But yeah, I'll hang about for like 5 minutes if you have any question. My hands are fine. Don't worry. I told you guys. I can stream for hours and hours and hours. But I appreciate you guys. I'm glad it helped. I'm glad it helped. I'd appreciate if you guys hit the like button before you go if you haven't already. Thank you guys so much. Thank you, thank you, thank you. Namer, I am gonna do this for the A-level lot as well. Thank you guys, thank you guys. We're raising the grey boundaries. So guys, James has actually put the link in the chat. If you guys want to review me on Trustpilot, thanks, James. You can just click that link, guys. It helps me out a lot. Thank you so much. You're welcome. You're welcome. Guys, just go get a good night's sleep is my recommendation. Thanks, Cartier. Make sure you subscribe for more content. Hit the like button. I'll see you guys in Cram 2. Make sure you guys let me know how you do after paper 1. Turkish Messi. I'll take it. I'll take it. But guys, don't do too much now. Don't do too much. I'd recommend you get a good night's sleep. All right. Tanushan, good luck tomorrow, man. Mimi, good luck. Motivation, that's incorrect, but yeah, you would get no marks for that. See you, Zep. See you, Arian. See you, Dian. Sophia, see ya. Aditya, see ya, man. Good luck tomorrow, guys. See ya, Yaz. See ya, Sabil. See ya, Wayne Rooney. Good luck tomorrow, homies. Good luck, good luck, good luck. You guys have got this. Raising the grey boundaries out here. Raising the grey boundaries. Azzy, would you do year 12 A-level maths tuition? Yeah, year 12, there will be tuition for year 12. Don't worry, guys. Don't worry. Thank you guys for the 5-star reviews. I appreciate it. Love for that. Said, what are the types of graphs we have to draw, like histogram, cumulative? Histograms usually comes up in calculator papers, but yeah, histograms, cumulative frequency, box plots. You've got frequency polygons. They could do as basic as a bar chart and line charts, but that's just plotting the frequency against the x value, right? Aria, yeah, loci can come up. But that's a foundation topic, so if you just need to watch a quick video on loci, it's not a big deal. It's quite easy. Thanks, Hyper. Thanks, Monty. 19, 20 meters. What's the one thing people make wrong on the ratio questions? I'm not sure, dude. You're welcome, Geordie, for the revision pack. I got you guys. Yes, Hermanic. There will be a stream for paper 2. Yes, to scene, exactly. See you, Jun. See you, DX. See you, Ramino. See you, Study Master. Vedish, where's my fries, little bro? See ya, Iru. Rashid, I can't do paper walkthroughs after you sat the test, otherwise I'll get sued for copyright. See ya, Om. Oh, Lung Gang for life. Alima, I got videos on them. We did it in lesson. Just go back to our lesson on it. Jacob, yes, with frequency polygons, you plot the midpoint. Come on, Emma. 3 to an 8, let's go. Aria, maybe one day. Aria, my Indian side of my family are from Gujarat, yeah. See ya, Maya. Yes, L, there'll be A-level sessions in the summer for free as well. You're welcome, Josh. See you. Thank you, Synthetic. Rashid, you've got this, man. See you, Douglas. DJP, it's more likely they will turn up in calculator paper. Abdullah Half. Christian of Mathematics. I'll take it. You. Thank you, thank you. Jonathan, if you use the AC method, keep using the AC method. Keep using it. Asaid, we did it in class. So go over the lesson. I'm not going to be able to explain it in enough depth. We did it not long ago. Maybe around Christmas. Mohammed, for frequency polygon, do you start from 0? No. So Mohammed, you start from the midpoint of the group. So curved line of best fit, that's not at GCSE. There's line of best fit, not curve of best fit. Thanks, Pravi. Tamzid, everything we did today. Sai, if you're gonna do anything before bed, I would just do maybe like one other paper, just to solidify knowledge. But I wouldn't be doing too much now. Yes, verbatim. You're welcome, Maya. See, Abbas, you're welcome. Good luck. Onosi, you can just go back on the stream. Leo, unfortunately, we don't have a cram for further maths, but I do have YouTube videos on it. Yeah. Guys, I know this might be a stretch, but I don't know if we can get to 2,000 likes. I'd really appreciate that. That'll be a milestone for me. But I know most people have left, so it's probably not going to happen. But it's all good. All good, Pravi. Aria, how do you prevent silly errors? You can't, unfortunately. Under exam pressure, you kind of have to accept that silly errors come with that. So yeah, there's no technique um, to getting rid of silly errors. Thanks, Jess, for the 5-star review. I appreciate it. Mystic, for cumulative frequency, do you start from 0? Yes, so you start from the beginning of the group. So the beginning of the group and 0 frequency. Let's say prepare for the shave. I will hopefully be going bold. See you, Shiesty. Very close to the 2K likes, guys. Thank you. Even if we don't hear, it's all good. It's probably because everyone in here has already liked the video. So thank you, guys. Yes, Rashid, for sure. Miriam, just get a good night's sleep. That's my best piece of advice for you now. Verbatim, I've already answered your question. S. The science crams are happening. Just go to the description, sign up, and we'll send you out the link. A, and all the revision questions are in it. So in the main module, they're all there. All the video solutions are there. Yeah, DJ, for sure. Thanks, Jaycon. Yes, Amber, for real. Leo, yeah, eventually, for sure. I'll have a dedicated maths teacher to do that. I didn't, Emmanuel. What was he doing? Thank you, guys. Good luck tomorrow. Yes, Mags, all my lessons are live. I don't believe in pre-recorded stuff. Unless it's during exam season when I physically can't teach the lesson. Yeah, Abdul. Yeah, 1920, like I did a geometry proof for the circle theorems. All right, guys. I'm going to start heading because you all need to be going to get some sleep as well. So good luck. Make sure you let me know how you do. I'll see you guys for cram session 2. On TikTok, I'll be uploading a video to ask you guys how you did. So good luck. Fingers crossed. Get some sleep. Don't panic. Maybe watch a couple of the questions we did today tomorrow on your way to school, but don't do too much, guys, because then you'll just stress yourself out. All right? So good luck. And yeah, I'll see you guys in the next session. So don't forget to leave me a trust pilot if you want to, if you enjoyed today and you learned something. And like the video, subscribe, and share the video with your mates. I'll catch you guys tomorrow. Good night, guys. See you later. Nice. Thank you, guys. Thanks, Jude. Thank you. Thanks, Skill Issue. Peace out, Mags. Azzy. Thanks, Om. All right, guys. Good night. See ya. I need to go eat my chicken, broccoli, and rice. Nice. See ya.